Picture this. You are floating in an expanse so vast and so profoundly dark that even the word emptiness feels insufficient. There are no stars here, no galaxies, no light or sound, only an endless, silent void stretching farther than any human mind can truly grasp. This is the space between universes, a realm of mystery so deep it challenges our very understanding of reality. As the cosmologist Max Tegmark once said, the universe is not only stranger than we imagine, it is stranger than we can imagine. And nowhere is that more true than in these intercosmic silences, the great cosmic voids that might hold secrets about existence itself. Why should we care about these vast stretches of nothingness? Because they are not truly nothing. These voids could hold the answers to some of our biggest questions: the origins of everything, the true nature of dark energy, the possibility of other realities just beyond our reach. This isn't just theoretical speculation. It's a journey into one of the most profound enigmas of cosmology, one that redefines our place in the cosmos. When you look up at the night sky, you're seeing only a fraction of what's out there. Beyond the glittering tapestry of stars and galaxies lies something deeper, something older, and something infinitely more mysterious. In this video, we're going to explore what lingers in those silent, unseen spaces. We'll delve into cutting-edge theories, scientific insights, and timeless philosophical questions, all in an effort to understand the shadows that move in the void. This is more than a tour of abstract ideas. It's an invitation to expand your perspective, to see the universe not as a fixed stage, but as one possibility among many. By the time we're done, you may never look up at the night sky in quite the same way again. So let's begin this journey together into the silence between the worlds. But to truly grasp the void, we must first unlearn what we think we know about emptiness. The vacuum of space within our own universe is not truly empty. It's a vibrant quantum field teeming with virtual particles flickering in and out of existence, awash with the faint glow of ancient radiation and crisscrossed by gravitational waves. It's a busy, active place. The intercosmic silence, however, is something else entirely. Imagine the deepest, most absolute quiet you can conceive, then push further. This void is a realm where the very concepts of here and there might dissolve, where time itself could have no anchor and no direction. It's not just an absence of stuff, it's a place where the fundamental rules that govern our reality may no longer apply, a true frontier beyond physics as we understand it. This idea is central to the work of physicists like André Linde, who champion the theory of eternal inflation and the multiverse. In this breathtaking view, our entire cosmos is just one bubble in a vast, frothing cosmic foam. Each of these bubbles is a universe with its own unique set of physical laws and constants, perhaps even different numbers of spatial dimensions, and what separates these islands of reality. An infinite, expanding ocean of true nothingness, the void. This isn't a passive emptiness but an active, generative substrate. It's within this primordial silence that the seeds of new universes are thought to be sown. Tiny quantum fluctuations, random ripples in the fabric of existence, can be stretched and amplified by this inflationary energy, potentially pinching off and inflating into entirely new cosmic bubbles, giving birth to whole new realities from the sheer potential of the void. This generative power makes the silence all the more eerie. We are accustomed to silence being a passive state, an absence of sound, but the intercosmic void represents an absence of everything, no matter, no energy, no forces, and crucially, no information. In our universe, even in the darkest, most remote void between galaxy clusters, information is carried by light, by gravity, by particles. We can learn about it. The true void between universes offers no such signals. It is the ultimate blind spot, a nothingness so complete that it could hide entire realities an infinitesimal distance away, forever separated from us by an unbridgeable gulf where not even a single photon could ever traverse. By understanding this profound distinction that the void is not a vacuum but a different state of existence altogether, we begin to see it not as a barren wasteland, but as a canvas of immense potential, setting the stage for the profound shadows and mysteries we will continue to explore. Long before telescopes peered into the depths of space or equations described the birth of universes, humanity was already gazing into the abyss, trying to give a name to the nothingness that surrounded existence. This ancient conversation with the void is one of our oldest intellectual traditions, a story written not in starlight but in the very fabric of our myths, philosophies, and fears. In the beginning, for many cultures, was not a thing, but a lack of things, a primal emptiness that held all potential. The ancient Greeks called it chaos, a yawning, formless gap that existed before the gods, a chasm of pure possibility from which the first deities emerged to create order. This wasn't a void of mere absence, it was a creative void, a necessary nothing that had to precede something. This concept of fertile emptiness finds a powerful echo in Eastern philosophies. In Buddhism, the principle of sunyata, often translated as emptiness or voidness, is a profound central tenet, but it is dangerously misunderstood if we think of it as simple nihilism or blankness. Sunyata does not mean that things do not exist. Rather, it describes the fundamental nature of reality, suggesting that all phenomena are empty of a separate, independent self. They exist only in relation to everything else. In this view, the void is not a bleak endpoint but the very source of interconnection and potential from which all things arise and to which they return. It is a cosmic dance of form and formlessness, a concept that feels startlingly modern when we consider today's quantum theories of particles flickering in and out of the vacuum. As human thought progressed into the Middle Ages in Europe, the debate became more structured, yet no less daring. Theologians and natural philosophers grappled with a seemingly simple question that was anything but, could a true vacuum exist? Aristotle had argued that nature abhors a vacuum, and this view held sway for centuries. But thinkers like Thomas Aquinas, working to reconcile faith with reason, engaged in intricate debates about whether God could create a void if he so wished. This was a high-stakes intellectual game, probing the limits of divine power and the very structure of creation. The void was no longer just a mythological concept. It was becoming a philosophical and theological problem, a puzzle about the nature of space and God's relationship to it. Then came the Renaissance, a rebirth of curiosity that shattered old certainties. In the late 16th century, the polymath Giordano Bruno took the audacious idea of the void and ran with it into the cosmos. A former Dominican friar with a fiercely independent mind, Bruno championed the Copernican model that placed the sun at the center of our system, but he went much, much further. He proposed that the stars were other suns, each with its own retinue of worlds, and that the universe was infinite. This meant that between these countless solar systems and island universes, there must be vast, unimaginable stretches of void. For Bruno, this was not a terrifying emptiness but a glorious expression of God's infinite creative power. The establishment, however, saw it as heresy. His ideas challenged the closed, earth-centered universe that supported the theological order of the day. for his visionary speculations on an infinite cosmos filled with infinite worlds separated by void. Giordano Bruno was tried by the Roman Inquisition and burned at the stake in 1600. His story is a stark, tragic reminder of the risks our ancestors took when they dared to contemplate the Great Silence. The scientific revolution gradually moved the question from the realm of philosophy and heresy into the realm of observation and mathematics. But the mystery persisted. Even Isaac Newton, who gave us the laws of motion and gravity, believed space was the eternal, unchanging sensorium of God, a divine framework that existed independently of the matter within it. It was a kind of absolute void, a stage upon which the cosmic drama unfolded. The real turning point arrived in the 20th century with Edwin Hubble's monumental discovery. By observing the redshift of distant galaxies, Hubble provided irrefutable evidence that the universe is not static but expanding. This was the key that unlocked the modern cosmological door. If the universe is expanding, what is it expanding into? The question of what lies beyond the leading edge of that expansion brought the concept of the external void roaring back into scientific relevance. At the same time, Albert Einstein was wrestling with his own version of the void. His theory of general relativity described gravity as the warping of spacetime by matter and energy. But when he applied these equations to the universe as a whole, they suggested a dynamic cosmos, one that should either be expanding or contracting. This contradicted the prevailing belief in a static, eternal universe. To force his equations to match this expectation, Einstein introduced a fudge factor which he later called his greatest blunder, the cosmological constant. This was a repulsive energy inherent to the vacuum of space itself, a latent force that would counter gravity and keep the universe balanced. Though he discarded it after Hubble's discovery, the concept has made a spectacular comeback in the form of dark energy, the mysterious force accelerating the expansion of the universe. Einstein's struggle shows that even our greatest minds have been both fascinated and confounded by the properties of nothingness. This entire historical journey reveals a deep and enduring pattern in the human psyche. Our fascination with the void is a tangled mix of curiosity and fear, a reflection of our eternal quest to find meaning in the face of the unknown. Whether envisioned as the chaotic womb of creation, the divine sensorium of God, the infinite expanse between worlds, or the enigmatic backdrop of an expanding cosmos, the void has always been the ultimate Rorschach test. We project our deepest hopes, our most profound dreads, and our most ambitious speculations onto its blank canvas. The shadows we search for today with our satellites and particle colliders are the same shadows that flickered in the flames of Giordano Bruno's stake and in the meditations of ancient monks. They are the ghosts that have always haunted the edges of our imagination, urging us to look deeper into the silence and dare to ask what might be looking back. So if the void is not a barren emptiness but a generative substrate, as we just explored, then what exactly is it generating? This brings us to one of the most mind-expanding ideas in all of modern physics, the multiverse. Think of it this way. We've spent centuries mapping our own cosmic neighborhood, charting the planets, stars, and galaxies within our universe. But what if our entire universe is just one house on an infinitely long street, in a cosmos-sized city we can't yet see? This is the core of multiverse theory, and it completely reframes our understanding of that intercosmic silence. It transforms the void from a meaningless nothing into the foundational space between worlds, the mortar in the bricks of reality itself. Physicists like Brian Greene and Max Tegmark have been instrumental in bringing these staggering concepts into the public eye. They suggest that what we call the universe, everything we can observe, from the nearest star to the most distant galaxy, might be just one single bubble in a vast, frothing cosmic foam. This broader structure is often called the meta-universe, and it could contain a countless number of these bubble universes, each with its own unique character. Imagine a universe where gravity is 10 times stronger, making life as we know it impossible, or a universe with 6 spatial dimensions where the very geometry of reality is unimaginable to our 3-dimensional mind. Or perhaps a universe where the nuclear forces are just slightly different, preventing atoms from ever forming, meaning that universe is forever a featureless hot soup of particles. The possibilities are as endless as the meta-universe itself, but how could such a fantastical idea possibly be grounded in real science? It all comes back to that generative void we discussed through a mechanism known as eternal inflation. This theory posits that the rapid expansion of spacetime that jump-started our universe, what we call the Big Bang, wasn't a one-time event. Instead, it's an ongoing process, a kind of background energy inherent to the vacuum of space itself. In this view, the meta-universe is a constantly and violently inflating expanse, but this inflation isn't perfectly uniform. Tiny quantum fluctuations, those same random pops of energy that create virtual particles, can cause local patches of this inflating space to suddenly pinch off. Think of it like a pot of water coming to a rolling boil. The whole pot is hot and energetic, but every now and then, a particularly large bubble forms and breaks away from the surface. In eternal inflation, that new bubble is an entire new universe, born from the seething energy of the void, instantly inflating and developing its own separate laws of physics, forever disconnected from its parent and its sibling universes. Another compelling version of the multiverse emerges from the complex mathematics of string theory. This approach is often called the string theory landscape. To understand it, we have to think in more dimensions. String theory proposes that the fundamental building blocks of reality are not point-like particles but tiny, vibrating strings. For the math to work, these strings vibrate in a reality that has 10 or 11 dimensions. We obviously only experience 3 of space and 1 of time. So where are the others? Theorists suggest they are compactified or curled up into shapes so incredibly small that we cannot perceive them. The specific way these extra dimensions are folded determines the physical laws and constants of a universe, like the strength of gravity or the mass of an electron. The mind-bending implication is that there could be a colossal number of possible ways for these dimensions to curl up, perhaps 10 to the 500 different configurations. Each configuration represents a unique universe with a unique set of physical laws. In this landscape, the void isn't just empty space between bubbles. It's a higher dimensional realm where all these possible universes exist as mathematical potentialities, like a cosmic catalogue of every possible reality. This is the profound shift in perspective that multiverse theory offers. The intercosmic silence is no longer a terrifying emptiness to be feared. It is a veil, a cosmic curtain drawn across a stage with an infinite number of plays happening simultaneously. We are audience members for only one performance, utterly unaware of the dramas unfolding just behind the thin fabric of spacetime. The shadows we ponder in the void, those faint, elusive presences we can only theorize about, might not be strange particles or dark matter structures. They might be the faint, gravitational echoes of our neighboring universes brushing up against our own, or the residual energy from a universe that collided with ours in the distant past. The silence isn't silent because there's nothing there. It's silent because we lack the ears to hear the cacophony of creation happening all around us. By reimagining the void as a cosmic neighborhood, we open the door to a reality far grander and more interconnected than we ever dreamed, where every shadow could be a window into another world. But if the void between universes is a canvas of creation, What happens when the canvas itself begins to stretch and warp in ways we are only beginning to understand? This brings us to one of the most pressing and mysterious forces in modern cosmology, a discovery so profound it upended our vision of the universe's destiny: dark energy. For much of the 20th century, scientists believed the universe's expansion, set in motion by the Big Bang, was gradually slowing down thanks to the relentless pull of gravity. The ultimate fate of the cosmos was a subject of fierce debate. Would it eventually collapse back on itself in a big crunch, or gradually coast to a halt? Then, in the late 1990s, two independent teams of astronomers made a shocking discovery that would win them the Nobel Prize. By meticulously observing distant supernova, they found that the universe's expansion isn't slowing down at all. It's speeding up. Something is actively forcing galaxies to fly apart from one another at an ever-increasing rate, and we call that mysterious something dark energy. This revelation completely rewrote the cosmic script. The leading theoretical culprit for this repulsive force is the cosmological constant, an idea first proposed by Albert Einstein and later abandoned as his greatest blunder. It represents a constant energy density inherent to the fabric of empty space itself. Think of the vacuum not as a true nothing, but as a seething quantum field. According to quantum mechanics, even in the deepest void, pairs of virtual particles are constantly flickering into and out of existence. This quantum jitter endows empty space with a tiny, intrinsic energy. Einstein's cosmological constant suggests that this vacuum energy exerts a negative pressure, a kind of anti-gravity that pushes space itself apart. The staggering implication is that the void is not passive. It is an active, dynamic player in the cosmic drama, with its own inherent energy that is relentlessly stretching the very fabric of spacetime. The long-term consequences of this are both profound and, for any conscious being, deeply isolating. As dark energy continues to accelerate the expansion of the universe, the vast cosmic voids that already exist between galaxy clusters will grow even larger and more permanent. Galaxies that are not already gravitationally bound to our local group will eventually be pushed beyond our cosmological horizon. Their light, no matter how powerful our telescopes become, will simply be unable to ever reach us again because the space between us is expanding faster than the speed of light. The universe will not end in fire or ice, but in a gradual, inexorable fade to black. This is the hypothesized heat death of the universe, a state of maximum entropy where the cosmos has expanded and cooled to a point of near absolute zero. All energy is evenly distributed, no work can be done, and the universe becomes a static, silent, and profoundly dark void. The observable universe will have become a lonely island, adrift in an eternal sea of nothingness, with all other islands of reality having vanished over the edge of forever. This terrifyingly empty future forces us to reconsider the very nature of the intercosmic silence we've been exploring. The voids between universes in a multiverse might be absolute and eternal, but the voids dark energy is creating within our own universe are a chilling echo of that ultimate fate. They are not the generative voids of eternal inflation, ripe with the potential for new universes. They are the opposite entropic voids, the end result of a cosmic story winding down. The shadows we might one day perceive in these expanding deserts of space could be the last, fading echoes of galaxies that have been pushed into unreachable exile, their stories forever lost to the silence. Dark energy, therefore, acts as a bridge between two concepts of the void: the external, intercosmic silence that may separate universes, and the internal, growing silence that is consuming our own from within. It suggests that emptiness is not a single state, but a spectrum, and that the destiny of all things may be to join the great silence, becoming one with the shadows that linger in the void. But if the void is an active force stretching our own universe into an ever-growing silence, then we must ask, what could possibly arise from such profound nothingness? The answer lies in the bizarre and counterintuitive realm of quantum mechanics, where the very concept of nothing loses all meaning. To understand this, we have to shrink our perspective down to the smallest scales imaginable, to a world governed not by the rigid certainty of classical physics, but by probability and potential. Here in the quantum foam, the vacuum of space is anything but empty. It is a seething, turbulent ocean of activity, a place where the laws of physics allow for something to come from nothing, if only for the briefest moment. This isn't poetic metaphor. It is a fundamental prediction of one of the most well-tested theories in all of science. The engine behind this incredible phenomenon is Heisenberg's uncertainty principle. In simple terms, this principle states that on the quantum level, there is a fundamental trade-off. You cannot know both the exact energy of a system and the exact time for which that energy exists with perfect precision. This isn't a limitation of our measuring equipment. It is a built-in feature of reality itself. This uncertainty creates a loophole in the law of energy conservation, which states that energy cannot be created or destroyed. On very short timescales, energy can literally borrow from the future, appearing out of nowhere as long as it disappears again almost instantly. This borrowed energy manifests as pairs of virtual particles, a particle and its antiparticle partner, that spontaneously pop into existence only to annihilate each other and vanish back into the vacuum a fraction of a second later. Empty space, therefore, is not a still pond but a boiling cauldron, fizzing with these fleeting particles. They are everywhere, even in the room around you right now, and their collective energy might even be the source of the dark energy pushing our universe apart. Now take this bizarre quantum behavior and project it onto the grandest canvas possible, the true void between universes. If our quantum vacuum is this active, what must the primordial, intercosmic void be like? Physicists like Alexander Vilenkin and Stephen Hawking applied this quantum logic to cosmology with a breathtaking proposal. They suggested that the same kind of quantum fluctuation that creates a virtual particle in a lab could, under the right conditions, create an entire universe from nothing. Imagine a region of the true void, a place of utter nothingness with zero energy. According to quantum law, a fluctuation could still occur. A tiny bubble of space-time could tunnel into existence from this nothingness, borrowing energy from the future of its own expansion. This process, known as quantum tunneling, allows a system to bypass an energy barrier that would be impossible to cross under classical physics. It's like a ball spontaneously appearing on the other side of a mountain without ever having to roll over the top. For this newborn universe bubble to survive and not instantly snap back into nothingness, it must undergo a process called inflation. Think of it like a microscopic seed that suddenly and violently expands, inflating faster than the speed of light, cooling and settling into the stable universe we recognize. This isn't just wild speculation, it's the leading theory for our own Big Bang. In this view, our entire cosmos, with its hundreds of billions of galaxies, could be the result of a single, incredibly fortunate quantum fluctuation in a greater void. This transforms our understanding of the intercosmic silence completely. It is no longer a barren wasteland or a graveyard for dying universes. It is a nursery. A genesis point, a creative engine of unimaginable power where the seeds of reality are constantly being sown. The shadows we wonder about in that vast darkness might not be ominous presences at all. They could be the faint, nascent glows of baby universes flickering into being, each one a new, self-contained reality with its own laws and history. This idea is pushed even further by the terrifyingly beautiful concept of vacuum decay. Our universe seems stable, but its stability might be a false vacuum. Think of the fundamental quantum fields that permeate everything like a vast landscape of hills and valleys. Our universe exists in a valley, but it might not be the lowest, most stable valley possible. It could be a metastable state perched precariously on a higher ledge, a sufficiently powerful quantum fluctuation, perhaps somewhere in the deep void, could act like a tiny nudge, causing a bubble of true vacuum to nucleate. This bubble would then expand at the speed of light, its walls rewriting the very laws of physics as they pass. The fundamental constants, the strength of gravity, the mass of an electron, would change instantly and permanently. This wouldn't just destroy life, it would annihilate the very potential for chemistry and physics as we know it, creating a new universe with entirely different rules in its wake. In this scenario, the void is not just a nursery but a catalyst for cosmic change, where a single, random event in the silence could erase one reality and replace it with another. So when we peer into the intercosmic abyss and see only silence, quantum mechanics tells us we are not seeing absence. We are looking at the ultimate potential. A cauldron of infinite possibility where the distinction between nothing and something is blurred beyond recognition. Every second of every day, the void is teeming with invisible activity, a quantum symphony of creation and destruction playing out on a scale we can scarcely imagine. The great silence is in fact the hum of potential itself, and we are living proof that from its restless nothingness, something magnificent can indeed arise. Yet if the quantum realm shows us a void bursting with creative potential, there is another fundamental force of nature that paints a far more somber and inevitable portrait of that same silence. This force is entropy, and it may hold the key to understanding why the deepest voids are not just empty, but are the ultimate expression of cosmic stillness. Entropy is often described as the measure of disorder in a system, but a more precise way to think of it is as the measure of uselessness. It's the slow, inexorable process where concentrated, useful energy, the kind that can power stars, planets, and life, spreads out and dissipates into a uniform, lukewarm background hum where no further work can be done. It's the reason a hot cup of coffee always cools to room temperature, never spontaneously reheating itself. It's the reason ice melts in a glass and why we remember the past but not the future. This is the second law of thermodynamics, and it is the only physical law that gives a definitive direction to time itself, an arrow pointing relentlessly toward equilibrium. Now project this law onto the grandest scale imaginable, the entire cosmos. The ultimate fate of our universe, according to this relentless logic, is a state known as the heat death. Imagine all the stars after trillions upon trillions of years, finally burning through their last reserves of fuel. One by one, they will wink out, leaving behind cold, dead remnants, black holes, neutron stars, and frozen cinders of planets. Even these massive structures are not forever. Through a process known as Hawking radiation, black holes themselves will slowly evaporate over almost unimaginable timescales. What remains is a universe that has expanded to its maximum limit, its energy now perfectly and evenly distributed across an infinite vastness. Every point in space is the exact same, incredibly cold temperature, just a fraction of a degree above absolute zero. In this state, no energy can flow because there are no hotter or colder places for it to go. No events can occur. No stars can form, no chemistry can happen, and no information can be exchanged or processed. It is the universe achieving a state of perfect, utter silence, the maximum possible entropy. This is where our contemplation of the void takes a profoundly chilling turn. When we peer into the intercosmic spaces between universes, we might not be looking at a creative nursery or a quantum foam. We might be gazing into the future. These voids could be regions that have already reached their heat death, pockets of existence that have achieved the ultimate equilibrium long before the rest of their parent universe. Or, in the context of the multiverse, the void separating bubble universes could be the default state of the meta-universe, a realm of maximum entropy that exists between islands of temporary, low-entropy order. Physicist Sean Carroll offers a fascinating perspective on this, suggesting that entropy isn't just a side effect of the cosmos, but may be the fundamental property that dictates its very structure. In his view, the Big Bang wasn't just the beginning of our universe. It was a moment of incredibly low entropy that set the entire cosmic clock ticking. The arrow of time flies because the universe started in an exceptionally ordered state and is now unwinding, spreading out, and seeking balance. From this vantage point, the shadows we have been wondering about in the great intercosmic silence take on a new and haunting identity. They are likely not alien structures, not dark matter creatures, nor even nascent universes. They are something far more abstract and perhaps more terrifying. They are the ghosts of future cosmic decay. They are previews of the absolute end of all activity, the final state of all things. The silence we detect is not an absence of sound, but an absence of difference, of gradient, of potential. It is the sound of equilibrium achieved. This adds a crucial and poignant temporal dimension to our journey. We are not just exploring a place, but we are also looking forward in time, billions upon billions of years, to witness the ultimate destiny of reality. The void becomes a mausoleum of time itself, a place where the arrow of time finally ceases to have meaning because there is no change left to measure. In the face of such profound silence, the vibrant, noisy, temporary universe we inhabit appears all the more precious and fleeting. But if the quantum foam and the slow creep of entropy describe the texture and fate of the void, they still operate within a familiar framework of space and time. What if the true nature of the intercosmic silence is something far stranger? A reality that operates on a completely different architectural blueprint. This is where string theory enters the stage, not with a whisper, but with a symphony of possibilities that completely redefines the stage itself. Our everyday experience is confined to a world of three spatial dimensions: length, width, and height, and one dimension of time. We move through this four-dimensional space-time, and it feels utterly complete. But what if this is merely the surface level of reality? String theory, one of the most ambitious frameworks in physics, proposes that the fundamental building blocks of the universe are not point-like particles, but unimaginably tiny, vibrating strings. And for the mathematics of these vibrations to produce the rich tapestry of particles and forces we observe, they must do their dancing in a reality that has not 4, but 10 or 11 dimensions. This immediately presents a colossal puzzle. If there are extra dimensions, where are they? Why don't we see them or fall into them? The prevailing answer is a concept known as compactification. Imagine a single strand of a spider's web. To an ant walking along it, the web is a one-dimensional path, a line. But to a human looking from a distance, that same strand is clearly a three-dimensional object with a certain thickness and circumference. The ant is simply too large to perceive the other dimensions of its world. In much the same way, string theory suggests that the extra 6 or 7 spatial dimensions are curled up or compactified into shapes so incredibly minute, on the scale of the strings themselves, known as the Planck length, that they are completely hidden from our perception. The specific, intricate geometry of these curled-up dimensions is absolutely crucial. It determines how the strings vibrate, and those vibrations are what manifest as all the different particles and forces in our universe. The mass of an electron, the charge of a quark, the very strength of gravity, all are dictated by the hidden shape of these unseen dimensions. Now, take this breathtaking idea and project it out into the great intercosmic void. Suddenly, that apparent emptiness is not empty at all. It is saturated with these compactified dimensions, a complex, higher-dimensional geometry that permeates all of what we mistakenly call nothingness. This is where the work of physicists like Lisa Randall becomes so revolutionary. She and others have explored a specific version of this idea called brain cosmology. In this model, our entire universe might not be floating in a higher dimensional void like a solitary bubble. Instead, it could be a three-dimensional brain, short for membrane, a vast, island-like structure existing within a higher dimensional space called the bulk. Think of our universe as a single, impossibly vast sheet of paper floating within a much thicker book. We are confined to the paper, unable to perceive the other pages or the space between them, but they are there. This vision of the cosmos utterly transforms the intercosmic silence. It is no longer a barren gap. It is the bulk itself, the higher dimensional space that contains all brains. And within this bulk, other universe brains could be floating just a microscopic distance away in a higher dimension, completely invisible and unreachable to us, yet right next door. This opens up staggering possibilities for what the shadows in the void might be. Could the dark matter that mysteriously holds galaxies together actually be the gravitational influence of matter on a neighboring brain, subtly leaking through the higher dimensional bulk into our own? Perhaps the great voids between galaxy clusters are not entirely empty, but are regions where the fabric of our brain wrinkles or curves, bringing us closer to the influence of another reality. The silence isn't silent, it's vibrating with the gravitational echoes of other worlds. The implications become even more dramatic when we consider that these brains might not simply float peacefully. They could be dynamic, moving through the bulk, and if they were to collide, the resulting transfer of immense energy could be exactly what we call the Big Bang. Our entire universe might be the aftermath of a cataclysmic collision between two brains in the higher dimensional void. In this scenario, the void is not just a passive container, it is an active arena for cosmic genesis. Furthermore, these brain collisions might not be a one-time event. They could be cyclical, happening over and over again across eternity, creating and recreating universes in an endless cycle. This means the intercosmic silence is not a permanent state but a phase between titanic events, a calm between storms of creation. So what might we actually be sensing when we detect the profound emptiness of space? According to string theory, we are not detecting an absence. We are brushing up against the limits of our perception. The shadows we project onto the void could be the faint, vibrational signatures of the strings themselves, the fundamental notes of the cosmic symphony, playing in dimensions we cannot access. Or they could be the literal shadows cast by other brains, other universes, passing through our own in the higher dimensional bulk. The great silence is in fact a veil. It is the curtain that hides the true backstage of reality, a realm of higher dimensions and vibrating membranes where the laws of physics are written not in particles, but in geometry and music. By embracing this string theory perspective, we don't just fill the void with stuff, we imbue it with an almost architectural grandeur, a hidden complexity that makes the cosmos feel more interconnected, more dynamic, and more mysteriously beautiful than we ever thought possible. Yet this scientific journey through quantum foam and higher dimensions only captures one facet of the great silence. To truly grasp the void, we must also turn inward, to the realm of human thought and meaning, where philosophers have wrestled with the concept of nothingness for millennia. Their insights reveal that the void is not just a physical place but a profound philosophical idea, one that shapes our very understanding of reality and our place within it. In the 20th century, thinkers like Jean-Paul Sartre and Martin Heidegger placed the concept of nothingness at the very center of human existence. Sartre, in his monumental work, Being and Nothingness, argued that consciousness itself is defined by a kind of nothingness. He distinguished between being in itself, which is the solid, complete existence of objects like a rock or a table, and being for itself, which is human consciousness. Our consciousness, Sartre claimed, is not a solid thing but a perpetual emptiness, a lack. It is this inherent nothingness within us that allows for freedom, choice, and the ability to imagine what is not yet real. We are constantly projecting ourselves into the future, creating ourselves through our actions, and this process is fueled by the void at our core. For Sartre, to confront nothingness is to confront the terrifying and exhilarating burden of our own radical freedom. His German contemporary, Martin Heidegger, approached the void from a different but equally profound angle in his seminal work, What is Metaphysics? Heidegger declared that the fundamental question of philosophy is, why is there something rather than nothing? This isn't just a scientific query about origins, it is a deep metaphysical shock. Heidegger argued that we truly encounter nothingness in moments of profound anxiety, a feeling not of fear toward any specific thing, but a dizzying awareness of the groundlessness of existence itself. In this anxiety, the familiar world seems to slip away, and we are faced with the sheer fact that things are, and that they might just as easily not be. This encounter with the void for Heidegger is not a negative experience to be avoided. It is the very thing that reveals being to us. By facing the abyss of nothingness, we are jolted out of our everyday complacency and can truly appreciate the miracle of existence. The void is the dark background against which the light of being shines forth. Now, take these powerful Western philosophical concepts and project them onto the intercosmic silence. The void between universes is no longer just an empty space. In a Heideggerian sense, it becomes the ultimate ground of possibility. It is the necessary nothing that allows every something to exist. Just as the silent pause between musical notes gives shape to the melody itself, the cosmic void might be the fundamental silence that defines and makes possible the symphony of existence. The shadows we wonder about are not merely physical anomalies. They are the metaphysical echoes of non-being, the necessary counterpart to being itself. This philosophical lens suggests that by studying the void, we are not just exploring the farthest reaches of space, but are also engaging in the most profound introspection, asking what it truly means to be. This perspective finds a powerful and harmonious echo in Eastern philosophical traditions, which have contemplated emptiness for thousands of years. In Taoism, the concept of wu or emptiness is not a negative void to be feared, but a creative principle. The classic Taoist text, the Tao Te Ching, states that the utility of a pot comes from the emptiness inside it, the space that can be filled. The usefulness of a window is in its empty space that lets the light through. Emptiness is not an absence but a potential, a receptive capacity that allows all things to function. The ultimate reality, the Tao, is often described as an infinite, empty void from which all of creation spontaneously arises. It is a vision of the cosmos as a continuous, dynamic dance between form and formlessness, where the void is the benevolent, generative mother of the 10,000 things. This stands in stark contrast to the thread of existential dread that often runs through Western conceptions of the void. While European thinkers often framed nothingness as a source of angst and alienation, a terrifying abyss that underscores the meaninglessness of life, Eastern philosophies have more frequently embraced it as a source of peace, wisdom, and unity. In Buddhism, the concept of sunyata or emptiness is the profound realization that all phenomena are empty of independent, permanent existence. Things exist only in relation to other things, in a vast, interdependent web of cause and effect. To realize this emptiness is not to fall into nihilism, but to be liberated from the illusion of a separate, solid self, and to achieve a state of compassionate connection with all of reality. The void, in this view, is not a cold emptiness but a warm interconnectedness. When we apply these ancient insights to our cosmic exploration, the intercosmic silence transforms once again. It is no longer a lonely, existential horror, nor is it merely a quantum nursery. It becomes the ultimate expression of sunyata, a vast, interdependent reality that is empty of the separate, isolated existence we project onto it. The apparent separation between universes might be an illusion of our limited perception. In a deeper, more fundamental way, all that is could be profoundly interconnected, with the void acting not as a barrier but as the very medium of that connection, a cosmic expression of the Buddhist concept of dependent origination. The shadows we detect might be the gravitational echoes of that deep interdependence, hints that the cosmos is a single, unified whole despite its apparent fragmentation. This philosophical journey forces a startling conclusion. Our quest to understand the intercosmic void is not a purely external, scientific mission. It is also an internal, metaphysical one. The silence we are trying to map and measure is not just out there in the cold depths of space. It resonates with a silence within our own consciousness. The same nothingness that defines the human condition, that allows for freedom and provokes anxiety, might be the same nothingness that serves as the canvas for the entire cosmos. The void's greatest mystery, therefore, may not be what physical objects it contains, but whether it possesses a nature that is somehow continuous with our own minds. Are we, in the deepest part of our being, staring into a mirror when we stare into the abyss? The shadows we seek in the great silence could be the reflections of our own consciousness, making this journey through the cosmos the most profound journey of self-discovery imaginable. But for all our theorizing about the generative quantum foam, the entropic fade to black, and the hidden dimensions of string theory, we are forced to confront a humbling and fundamental limitation. We are, in a very real sense, prisoners of our own cosmic bubble. The grand visions of the multiverse and the intricate nature of the void remain, for now, spectacularly beautiful ideas locked in the realm of mathematics and imagination. The reason is brutally simple: we cannot see it. Our entire view of the cosmos is constrained by a hard, physical barrier known as the cosmological horizon. Imagine the universe is an immense, expanding balloon, and we are a tiny dot on its surface. We can only see the other dots, the distant galaxies, that are close enough for their light to have had time to reach us since the beginning of the expansion. The observable universe is everything within that line of sight, a sphere centered on Earth with a radius of about 46.5 billion light-years, making its total diameter a staggering 93 billion light-years. This is our entire reality, our only dataset. Anything beyond that horizon is forever hidden from our view because the space between us and those regions is expanding faster than the speed of light. Not even light itself, the fastest messenger in the cosmos, can outtrace this expansion to ever bring us news from the other side. The true, full extent of the cosmos and the nature of the void that might surround it or exist between its parts is fundamentally and perhaps permanently veiled from our observation. This creates a profound observational challenge. The intercosmic silence we've been exploring is, by its very definition, outside our observable universe. It is a realm that does not interact with the electromagnetic force, It emits no light, reflects no light, and absorbs no light. Our primary tool for understanding the universe, the telescope, is rendered completely useless. It is like trying to study the depths of the ocean by staring into a thick, impenetrable fog from a boat on the surface. We are trying to map a territory that is, for all intents and purposes, a literal blind spot in our charts of existence. This forces cosmologists to become cosmic detectives, relying entirely on indirect evidence and subtle clues to piece together a picture of what lies in the great beyond. The most powerful piece of evidence we have is the fossilized glow of the Big Bang itself, the cosmic microwave background radiation. This faint, uniform microwave static that fills all of space is a baby picture of the universe from about 380,000 years after its birth. By meticulously mapping its tiny, infinitesimal fluctuations in temperature anisotropies that are mere millionths of a degree, scientists can infer the initial conditions of the universe and test theories about its origin and ultimate structure, including the possibility of an inflationary multiverse. It is an echo from the dawn of time, and within its subtle patterns, we might find the faint, gravitational fingerprints of other universes brushing up against our own in the primordial void, or evidence of the quantum seeds that spawned everything. Beyond this ancient light, researchers turn to powerful computer simulations. Using the known laws of physics, they can create vast, virtual multiverses, running the clock forward from the Big Bang to see if the structures that emerge, the distribution of galaxies, the presence of cosmic voids, match what we actually observe with our telescopes. If a simulation that assumes a certain type of multiverse and a specific nature of the intercosmic void produces a virtual universe that looks exactly like our own, it lends credence to the idea that the model might be correct. It is a way of testing ideas that are, for now, untestable by direct experiment. The frustration of this indirect approach is palpable, but it is matched by an equal measure of wonder, as each new generation of technology pushes the boundaries of what is possible. The James Webb Space Telescope, for instance, is not looking into the void between universes, but by peering back to the very first stars and galaxies, it is helping us understand the precise conditions of cosmic infancy, which in turn helps us refine our models of inflation and what might have come before. Even more tantalizing are the next-generation observatories on the drawing board, particularly gravitational wave detectors. Gravitational waves are ripples in the fabric of spacetime itself, caused by the most violent events in the universe, like colliding black holes. Future space-based detectors, like the proposed Laser Interferometer Space Antenna, or LISA, could potentially detect the faintest gravitational wave background, a permanent rumble left over from the inflationary epoch. Within that rumble, there might be signals of cosmic strings, defects in space-time, or even the echoes of collisions between our universe and others in the multiverse. It would be like developing a new sense, allowing us to hear the vibrations of the cosmos in a way we never could with light alone. Yet, despite these incredible technological strides, we must be honest with ourselves. The void, in its truest sense, remains almost entirely speculative. It is the ultimate frontier, and it may forever lie beyond the reach of empirical confirmation. This inherent limitation is not a failure of science. It is a defining characteristic of the mystery itself. It forces a certain humility upon us, a recognition that some corners of reality might be forever shrouded in shadow, accessible only to the tools of logic, mathematics, and the boundless human imagination. This very inaccessibility is what fuels both our frustration and our fascination in equal measure. The shadows we ponder, those theoretical entities, other universes, or higher dimensional structures, are forever just beyond our grasp, teasing us from the other side of an unbridgeable gulf. They become modern-day myths, shaped not by superstition but by the most advanced equations we can devise. And in that space between knowledge and mystery, between what we can prove and what we can dream, lies the enduring allure of the intercosmic silence, a reminder that the universe is still vast enough to hold secrets beyond our wildest comprehension. So if the void is not a true nothingness, but a realm buzzing with quantum potential and threaded with higher dimensions, what forms might that activity take? What strange inhabitants could be lurking in that profound darkness, forever hidden from our sight? Let's open a catalogue of cosmic curiosities, a gallery of theoretical shadows that might call the intercosmic silence home. First on our list are some of the oldest and most massive potential residents, primordial black holes. Unlike the stellar black holes formed from collapsing stars or the supermassive ones anchoring galaxies, these would be relics from the universe's first frantic moments. Imagine the cosmos less than a second old, a seething, ultra-dense soup. Tiny, random fluctuations in density could have collapsed under their own gravity, pinching off into black holes of almost any size, from a mere asteroid's mass to thousands of times that of our Sun. Billions of these ancient objects could have been born in that initial chaos, and many may have been flung into the deep voids during the violent formation of the cosmic web. They would be invisible, of course, but their presence could potentially be betrayed by the subtle way their immense gravity warps the light of more distant objects, a phenomenon known as gravitational lensing. Finding one would be like discovering a living fossil from the dawn of time, a silent witness to the universe's birth, drifting in the eternal night. But it's not just colossal gravitational traps that might be adrift. Consider a far lonelier fate, that of rogue planets. These are worlds that have been violently ejected from their home solar systems, perhaps by a gravitational slingshot encounter with a larger planet. Once torn from their star's warmth, they would embark on an endless journey through the freezing blackness of intergalactic space. A planet like Earth, stripped of its star, would see its oceans freeze solid and its atmosphere collapse into an icy shell on the surface within a few million years. Yet, intriguingly, it might not be entirely dead. Tectonic activity or the decay of radioactive elements in its core could provide just enough heat to maintain a subsurface ocean, much like those suspected to exist on moons like Europa or Enceladus. In the lightless, deep frozen abyss of the void, such a world could, against all odds, harbor a tenacious form of life, utterly isolated and unaware of any universe beyond its icy crust. These frozen wanderers would be virtually impossible to detect, their faint infrared glow lost in the immensity of nothingness, making them some of the most common yet most secretive inhabitants we can imagine. Then there is the most pervasive shadow of all, dark matter. We know it exists because of its gravitational grip on galaxies, but we have no idea what it actually is. It does not emit, absorb, or reflect light, it simply is. And while it is concentrated around galaxies, it is also everywhere, permeating the vast cosmic voids. Could it clump together in there in ways we haven't predicted? Without the disruptive gravitational forces of normal matter, might dark matter form its own intricate structures, invisible rivers, sheets, or even dark galaxies drifting through the emptiness? Some theories even suggest that dark matter particles could interact with each other through forces we don't yet understand, potentially giving rise to a shadowy, complex ecology of dark matter objects that we are completely blind to. The void, in this view, is not empty at all. It is a thriving metropolis of dark matter, a parallel universe of mass that we can only sense by its subtle tug on the light of distant galaxies. Moving into even more speculative territory, the work of theoretical physicists like Laura Mersini Horton suggests the void could be a cosmic archive. Her research into the wave function of the universe implies that the quantum information describing other universes in the multiverse could be imprinted on our own cosmic microwave background radiation. In this mind-bending view, the void isn't just a space between worlds, it's a hard drive. The faint temperature variations we see in the ancient afterglow of the Big Bang might not just be random noise, they could be a holographic projection, a quantum fingerprint left by neighboring universes brushing up against our own in the higher dimensional bulk. Decoding those patterns would be like discovering a library of everything, a record of all possible realities, written in the subtle geometry of the void itself. This leads us to the outer limits of what is scientifically plausible and into the realm of profound metaphysical speculation. Consider the Boltzmann brain. This is a thought experiment born from thermodynamics, named for the physicist Ludwig Boltzmann. It posits that in an infinite universe or an eternal multiverse, random quantum fluctuations could, given enough time, spontaneously assemble a fully formed, conscious brain, complete with false memories of a life it never lived. The probability of this happening is astronomically, mind-crushingly low, but in an infinite void over infinite time, probability becomes inevitability. The truly unsettling implication is that it is vastly more likely for a single conscious entity to randomly fluctuate into existence in a void than for an entire ordered universe like ours to evolve naturally. Are we perhaps just such a fluctuation, a momentary spark of awareness in an eternal darkness, soon to dissolve back into the chaos? The Boltzmann brain is the ultimate ghost in the cosmic machine, a shadow of a thought that forces us to question the very nature of our own reality and our place in a potentially absurd and random cosmos. Finally, we must consider the most destructive shadow of all, the threat of vacuum decay. As we discussed, our universe might exist in a false vacuum state, a precarious valley in the landscape of quantum fields. Somewhere in the void, a single quantum fluctuation could be all it takes to nucleate a bubble of true vacuum. This bubble would expand at the speed of light, its walls rewriting the fundamental laws of physics as they pass. The strength of gravity, the nature of atoms, the very concept of chemistry, everything would change instantly and permanently. There would be no warning. One moment, the universe would be as it is. The next, a wave of absolute alteration would sweep through reality, erasing everything we know and replacing it with something utterly unknowable. This isn't an explosion. It's a translation of existence into a new language where life and matter as we understand them have no meaning. The void, then, is not just a home for curiosities. It could also be the birthplace of the ultimate cosmic eraser, a shadow that holds the power to unmake all of reality in an instant. Each of these possibilities, from the frozen rogue planets to the universe-ending vacuum bubbles, transforms the intercosmic silence from a mere emptiness into a place of infinite potential and infinite mystery. It is a gallery of the cosmos's strangest ideas, a testament to the fact that nature's imagination far exceeds our own. Yet for all its potential as a cosmic archive or a quantum nursery, the intercosmic void may also serve as the ultimate prison wall, a barrier of such profound and absolute nature that it forever isolates islands of reality from one another. Imagine discovering that you live on the most beautiful island imaginable, with lush forests, vibrant ecosystems, and a rich history, but then learning that your island is the only one in an infinite, unnavigable ocean, and that you are utterly and permanently alone. This is the chilling possibility that emerges when we consider the practicalities of communication across the meta-universe. Even if the multiverse is teeming with other universes, each potentially filled with their own forms of life, consciousness, and wonder, the void between them may render them forever invisible, unreachable, and unknowable to us. The very laws of physics that allow for our existence might also be the chains that bind us to our own cosmic cell. The most fundamental of these chains is the speed of light. In our universe, nothing can travel faster than this universal speed limit. This isn't just a limitation of our technology. It is a foundational pillar of reality, as described by Einstein's theory of relativity. This means that any signal we might try to send, a radio wave, a laser beam, a gravitational wave signature, would take an incomprehensibly long time to travel even within our own universe. To cross the gulf to another universe, separated by a void where the very concept of distance may break down, would be impossible. A signal would simply never arrive. It would be lost in the infinite expansion, its energy diluted to nothingness long before it ever reached another shore of reality. We are like sailors on a ship, sending messages in bottles into a hurricane-racked sea, with the faint hope that one might somehow reach another ship we cannot even see. This isolation is perfectly encapsulated by the concept of the Hubble volume, also known as the observable universe. This is our cosmic horizon, the absolute limit of what we can ever see or interact with. It is a sphere centered on us with a radius of about 46.5 billion light-years. Every galaxy, every star, every photon of light that we will ever receive is contained within this bubble. Everything outside this bubble is, and will forever remain, hidden from us because the space between us and those regions is expanding faster than light can traverse it. Now take this concept and apply it to the multiverse. If our entire universe is one bubble in a foam, then our Hubble volume is just a tiny speck within that bubble. The void between our bubble and the next is immeasurably vaster, and it is likely expanding at a rate that makes the expansion within our universe seem placid by comparison. The other bubbles are not just over the horizon, they are beyond all possible horizons, separated by a silence so complete that not even information can breach it. Human ingenuity, of course, immediately reaches for theoretical loopholes. Could wormholes, theoretical tunnels through space-time, provide a shortcut? The mathematics of general relativity does allow for such structures, often called Einstein-Rosen bridges. Renowned physicist Kip Thorne has extensively studied their properties, but the conclusions are daunting. To create or stabilize a wormhole large enough for even a particle to traverse would require energies of an unimaginable scale and a form of matter with negative energy density, something we have never observed. The engineering challenges are so far beyond our comprehension that they might as well be magic. Similarly, ideas like warp drives, which would contract space in front of a ship and expand it behind, also rely on exotic matter and energies comparable to those output by entire stars. These are not technologies waiting to be invented. They are speculations on a chalkboard, highlighting not our potential, but the immensity of the barriers we face. This leads us to a profound and deeply human realization: cosmic loneliness. For centuries, we have looked to the stars and wondered if we are alone. The discovery of the multiverse seemed to offer the ultimate comfort. Of course, we are not alone. There must be infinite versions of reality out there. But this new perspective reveals a far more poignant truth. We may not be alone in the grand scheme of existence, but we are utterly alone in our ability to ever know that for certain. The multiverse, in this light, becomes the ultimate tease, a promise of companionship that is forever withheld by the very fabric of reality. The silence is not just an absence of sound, it is an absence of connection. It is the silence of a phone line that has been cut with no hope of repair. The shadows we sense moving in the void, those tantalizing hints of other realities, may indeed be our neighbors. But they are neighbors in the way that two prisoners in solitary confinement, in cells on opposite sides of a planet, are neighbors. We might share the same fundamental reality, but we are infinitely far apart, destined to live out our existence in a silence that is the most perfect and unbreakable barrier imaginable. Long before telescopes or particle accelerators, humanity was already mapping the deepest reaches of nothingness, not with equations, but with stories. These ancient narratives, passed down through countless generations, reveal a profound and universal intuition that before form there was formlessness, before something there was a generative nothing. This timeless human impulse to give a name and a story to the void is perhaps one of our most enduring attempts to find our place within the immense and often terrifying cosmos. Across continents and cultures, we find a strikingly consistent theme, a primordial emptiness that is not merely an absence, but a womb of potential, a sacred silence that precedes the symphony of creation. Consider the Norse conception of the beginning, a universe born from the clash between fire and ice within the great void they called Ginnungagap. This wasn't a passive emptiness. It was a dynamic and charged space, a yawning gap that held within it the seeds of all that would come. From the meeting of the elemental realms of Muspelheim and Niflheim within this gap, the first being, the giant Ymir, was formed. Here, the void is the essential stage, the necessary condition for the drama of creation to unfold. It is the blank page upon which the saga of the gods and the world is written. Similarly, in the rich tapestry of Aboriginal Australian cultures, the Dreamtime describes a period before the world took its present shape, a kind of potentiality where ancestral spirits moved through a formless landscape, singing the mountains, rivers, and creatures into existence through their journeys and deeds. The emptiness was not a void to be feared, but a realm of pure becoming, a canvas awaiting the brushstrokes of creation. This vision of the void as a container of infinite possibility finds one of its most sophisticated expressions in Hindu philosophy with the concept of Brahman. Brahman is the ultimate, unchanging reality, the cosmic principle underlying the universe. It is often described as Sat Chit and Ananda, being, consciousness, and bliss. But crucially, it is also understood as a kind of divine nothingness, a void that is paradoxically full. It is the source from which the myriad forms of the manifested universe, known as Maya, arise and into which they eventually dissolve. This is not a nihilistic emptiness, but a plenum of potential, a reality that contains all possible realities within it. The resonance with modern multiverse theory is astonishing. Just as Brahman is the singular, transcendent source of all apparent multiplicity, the quantum vacuum, or the higher dimensional bulk of string theory, is the singular ground from which a potentially infinite number of bubble universes with different physical laws can spontaneously emerge. The ancient seers and the modern physicists, though separated by millennia and methodology, seem to be pointing toward a similar profound truth, that the deepest ground of reality is a fertile void. Faced with the terrifying incomprehensibility of this nothingness, our ancestors did what humans do best. They populated it. They gave the shadows in the void a face, a name, and a story. The formless chaos became personified as gods, monsters, and ancestral spirits. In the Babylonian Enuma Elish, the primordial chaos is represented by the goddess Tiamat, a monstrous, watery abyss who is slain by the god Marduk to create the ordered world from her divided body. The void is not just a place, it is a character, an antagonistic force that must be overcome to establish cosmos. In ancient Egyptian mythology, the universe emerges from the dark, limitless waters of Nun, a primordial ocean that represents non-existence and chaos, yet which also contains the potential for all life. The gods themselves are born from this void. These stories are more than just primitive attempts to explain the unknown. they are profound psychological and metaphysical frameworks. By giving the void a personality, our ancestors were able to engage with it, to negotiate with it, to find a way to live in a world that emerged from a mystery they could never fully comprehend. The monsters and gods are the shadows we cast onto the abyss, giving shape to our deepest fears and highest aspirations about the nature of existence. This desire to bridge the gap between the terrifying unknown and the human need for meaning is a thread that connects the earliest campfire stories to the most advanced scientific papers. The journey through the intercosmic silence that we are on today is not a departure from this ancient quest. It is its latest chapter. We have traded the language of gods and monsters for the language of mathematics and quantum fields, but the fundamental impulse remains unchanged. We are still trying to tell a story about where we came from and what lies beyond the edge of our understanding. The equations of inflation are our creation myth. The multiverse is our pantheon of possible gods. The search for dark matter is our way of mapping the shadowy monsters that we know must be there, even if we cannot see them directly. This connection between ancient myth and modern science is not to say that they are the same. The scientific method provides a tool for testing and verifying our ideas against reality in a way that mythology does not. But it does reveal something essential about the human spirit. We are meaning-making creatures, and the greatest meaning is often found not in the answers, but in the search itself. The void, in all its forms, has always been our greatest teacher and our greatest muse. It forces us to confront the limits of our knowledge and to imagine what might lie beyond. Whether we are storytellers gazing at the stars or physicists gazing at a whiteboard, we are participating in the same timeless human endeavor. The audacious, beautiful, and profoundly human attempt to find a glimmer of light in the overwhelming darkness, and to hear an echo of our own story in the great intercosmic silence. Yet after tracing the void through equations and ancient myths, we are left with a question that brings our journey from the cosmos directly back to ourselves. Why does this profound nothingness hold such a powerful grip on the human imagination? The answer lies not in the stars, but deep within the architecture of our own minds. Human psychology has a complex and deeply ambivalent relationship with silence and emptiness, a reaction that is equal parts magnetic attraction and primal fear. The renowned psychologist Carl Jung saw the void as one of the most potent symbols of the unconscious mind itself, a vast, uncharted territory teeming with latent potentials, forgotten memories, and archetypal shadows that both terrify and fascinate us. To stare into the cosmic abyss is, in a very real psychological sense, to stare into the abyss of our own inner world, a place where the known structures of our ego and identity dissolve into something much larger and more mysterious. This psychological push and pull is driven by two of our most fundamental instincts, our innate curiosity and our deep-seated fear of the incomprehensible. Our brains are pattern recognition machines, hardwired to seek out meaning, narrative, and cause and effect in everything we experience. The intercosmic silence represents the ultimate patternless state, a complete absence of the familiar signals we use to navigate reality. This triggers a deep cognitive dissonance. It is an unsolvable puzzle that our minds cannot help but try to solve, drawing us in with an almost gravitational pull. Simultaneously, that same featurelessness activates our most ancient survival instincts. In the wild, silence can be a warning sign, the quiet before a storm, the hush that falls when a predator is near. On a cosmic scale, the void is the ultimate predator, a presence that threatens not our physical body, but our very understanding of reality and our place within it. It represents the possibility of absolute irrelevance, a universe utterly indifferent to our existence, and that is a profoundly unsettling thought to confront. We see this deep psychological ambivalence reflected and explored throughout human culture, especially in art and storytelling. The void has long served as a powerful canvas onto which we project our deepest existential fears and our most sublime wonders. In literature, the genre of cosmic horror, pioneered by writers like H.P. Lovecraft, uses the vast, uncaring emptiness of space to evoke a sense of thrilling dread. Lovecraft's famous dictum that the oldest and strongest emotion of mankind is fear, and the oldest and strongest kind of fear is fear of the unknown, finds its perfect embodiment in the silent, dark spaces between the stars, which he populated with ancient, god-like entities that shatter human sanity. His stories are not about monsters in the traditional sense, but about the psychological impact of encountering something so vast and alien that it renders human concerns utterly meaningless. The true horror is the void itself and the terrifying realization of our own insignificance within it. Conversely, the void can also inspire a sense of sublime awe and spiritual wonder. Stanley Kubrick's cinematic masterpiece 2001, A Space Odyssey, uses the stark silence of space not to horrify, but to evoke a profound sense of grandeur and mystery. The long, silent sequences of spaceships drifting against the backdrop of infinite blackness, accompanied only by the haunting strains of classical music, are not meant to frighten but to mesmerize. They create a feeling of contemplative awe, forcing the audience to sit with the sheer scale and beauty of the cosmos. Kubrick uses the visual and auditory void as a meditative tool, a way to quiet the noisy human world and open a door to a more transcendent state of consciousness, hinting at the next step in human evolution. This duality shows how the same emptiness can be a source of both our deepest dread and our most elevated inspiration, a mirror reflecting the conflicting depths of our own psyche. This exploration is not confined to classic works, it permeates modern media as well. The video game Dead Space uses the claustrophobic silence of a derelict starship to create unparalleled psychological terror, where the absence of sound is more frightening than any monster's roar. Meanwhile, the ambient, minimalist music of composers like Brian Eno crafts soundscapes that emulate the void to produce feelings of calm, spaciousness, and intellectual expansion. His album Ambient One, Music for Airports, uses sparse, drifting notes and long silences to create a sense of peaceful emptiness, a mental refuge from the overcrowded modern world. These artists are all exploring the same psychological territory from different angles, demonstrating that our response to the void is not monolithic but a complex spectrum of emotions. This emotional and psychological dimension is not a sidebar to our scientific exploration. It is its essential complement. It reminds us that the quest to understand the intercosmic silence is never a purely objective external mission. We are not detached observers charting a distant land. We are conscious beings, products of that same cosmos, trying to find our reflection in the deepest possible dark. The shadows we project onto the void, whether as ancient gods, alien monsters, or cold dark matter, are often the shadows of our own unconscious, the parts of ourselves we have yet to understand. The great, silent abyss between universes becomes the ultimate Rorschach test, and what we see in its inkblot depths tells us less about the nature of reality and more about the nature of the mind that is doing the looking. Our journey through the cosmos is, therefore, also a journey of self-discovery, and the final frontier may not be in the stars but within. For now, the void between universes remains a realm of pure theory, a tapestry of shadows woven from mathematics and imagination. But the history of science is a story of turning the impossible into the routine, of building new eyes to see what was once invisible. Our inability to directly observe the intercosmic silence is not a permanent barrier. It is the very challenge that ignites our ingenuity, driving us to develop tools that can listen for the faintest echoes of creation itself. The next great leap may come from finally weaving together the two great pillars of 20th century physics, general relativity and quantum mechanics, into a single, unified theory of quantum gravity. This holy grail of physics would provide us with the first complete language to describe the conditions of the primordial void, telling us precisely how space-time itself might emerge from a state of nothingness. While a full theory remains elusive, experiments are already pushing forward. Projects like the Laser Interferometer Gravitational Wave Observatory, or LIGO, have given us a thrilling preview by detecting ripples in space-time from colliding black holes. But this is just the beginning. The Future Laser Interferometer Space Antenna, known as LISA, represents a monumental upgrade. Imagine a constellation of 3 spacecraft flying in a perfect triangular formation millions of miles apart, connected by lasers. This immense observatory, floating in the silence of space, will be exquisitely sensitive to the low-frequency hum of the cosmos. It could detect the gravitational waves from the merging of supermassive black holes, but even more tantalizingly, it might hear the faint rumble left over from the Big Bang itself, or the vibrational signatures of cosmic strings, hypothetical defects in spacetime that could be threads leading us right back to the void structure. Beyond listening to the cosmos, we are learning to recreate its most extreme conditions in laboratories on Earth. Particle accelerators like the Large Hadron Collider smash protons together at nearly the speed of light, briefly generating temperatures not seen since the universe's first moments. While we cannot create a new universe in a detector, these experiments allow us to probe the stability of the quantum vacuum and the fundamental fields that permeate all of reality. By studying the results of these incredible collisions with immense precision, physicists can test the parameters that might determine if our universe is truly stable or merely metastable, perched on the edge of a catastrophic vacuum decay that could be triggered from the void. This is not just abstract science, it is a direct investigation into the ultimate fate of everything, conducted in a controlled, albeit spectacular, environment. Alongside these massive machines, tabletop experiments are exploring the quantum nature of gravity itself. By cooling tiny objects to near absolute zero and observing their behavior, scientists hope to see quantum effects play out on a human scale, potentially revealing how gravity interacts with the quantum world at the very edge of existence. The quest is not limited to physical instruments. The sheer complexity of multiverse models and the mathematics of string theory landscape is so vast that the human mind alone cannot navigate it. This is where artificial intelligence and machine learning are emerging as indispensable partners in our exploration. These powerful tools can process astronomical datasets, searching for anomalous patterns in the cosmic microwave background that might be the gravitational imprint of a neighboring universe. They can run near-infinite simulations of cosmic inflation, playing with different variables to see which models produce a virtual universe that looks exactly like our own. An AI doesn't get bored or overwhelmed. It can tirelessly explore the 10 to the 500th power possible universes in the string theory landscape, looking for the narrow pathways that lead to a reality capable of supporting life. In a very real sense, we are building digital oracles not to predict the future, but to map the possibilities of the past, using silicon and code to venture into territories where matter and energy cannot yet go. Each of these efforts, from space-based gravitational observatories to subterranean particle colliders and digital universes, represents a different strand in a single grand project, humanity's relentless drive to illuminate the shadows. We are building a ladder of inference where each new piece of evidence, whether from observation, experiment, or simulation, provides another rung to climb higher, to see a little further into the dark. The silence may be profound, but it is not necessarily permanent. The whispers of the void may be all around us, encoded in the faintest gravitational waves, hidden in the quantum jitter of a supercooled crystal, or waiting to be decoded by an algorithm we have yet to invent. This forward-looking perspective transforms our journey from one of passive contemplation to active participation. We are not merely observers of the cosmic mystery. We are detectives, engineers, and explorers, slowly and methodically assembling the tools that might one day turn the most profound speculation into testable, tangible science. The great intercosmic silence is the ultimate cold case, but we are just beginning to learn how to listen. But as we stand on this precipice of potential discovery, our hands reaching for the tools that might one day let us touch the void itself, we are forced to pause and ask a question that is as ancient as it is urgent. Just because we can, does it mean we should? The drive to explore is etched into our very DNA, a burning curiosity that has propelled us from the savannas to the stars. Yet, for the first time, our curiosity could have consequences that reach beyond our planet, beyond our solar system, even beyond the very boundaries of our universe. The intercosmic silence may be the final frontier, but it is also a realm of profound and unknown fragility. To venture into it is not like sailing uncharted oceans. It is more like entering a sacred, silent cathedral that has stood empty for eternity, and we must ask ourselves what gives us the right to shatter that silence with our footsteps. The most stark and terrifying risk is the possibility that our very act of observation or interaction could trigger a cataclysm. This is not science fiction. Within the framework of quantum field theory, there exists a legitimate hypothesis known as vacuum decay. Imagine our universe is not in its most stable possible state, but is instead perched in a precarious false vacuum, a valley of stability that is not the lowest point on the cosmic energy landscape. Our reality, with its specific laws and constants, depends entirely on this delicate balance. Now, imagine that a high-energy experiment, perhaps one designed to probe the very fabric of space-time or to create a microscopic black hole, provides just enough energy to push a tiny region of space over that ridge and into the true vacuum. This would create a bubble of a new reality with fundamentally different physics. This bubble would then expand at the speed of light in all directions, its wall rewriting the laws of nature as it passes. There would be no warning, no alarm. One moment, the universe as we know it would exist. The next, it would be erased and replaced by something utterly alien, where atoms cannot form and life is impossible. Our entire cosmic history, every star, every planet, every human thought and achievement would be annihilated in an instant. The price of satisfying our curiosity could be the unwitting destruction of all existence. Beyond this ultimate risk lies a more subtle but equally profound ethical dilemma, the potential for contamination. This principle is already a cornerstone of our space exploration here in our own solar system. NASA meticulously sterilizes probes sent to Mars or the moons of Jupiter to avoid any possibility of terrestrial microbes hitchhiking a ride and irrevocably contaminating a pristine alien ecosystem, which would destroy our ability to ever know if life there was truly indigenous. Now expand that concept to a multiversal scale. If the void is indeed a nursery for nascent universes, or if it contains other, fully formed realities, our mere presence could be an act of irreversible pollution. Our physics, our quantum signature, even our conscious observation might seep into these virgin realms. altering their development in ways we cannot predict or control. We would be the invasive species on a cosmic scale, the bull in the china shop of creation. Do we have the right to impose our footprint on realities that have evolved or could evolve entirely independently of us? The precautionary principle, which advises erring on the side of caution when faced with potentially catastrophic and irreversible outcomes, would suggest we should not. It calls for humility, arguing that the sheer scale of the potential downside, the complete destruction or corruption of entire cosmic ecosystems, demands that we restrain our ambition. This conversation inevitably leads us to the mind-bending simulation hypothesis popularized by philosophers like Nick Bostrom. If it is even remotely possible that our universe is not base reality, but an artificial simulation running on some unfathomably advanced computer in a higher reality, then our attempts to probe the void take on a completely different ethical dimension. Poking at the boundaries of our simulated universe could be seen as a form of hacking, an attempt to break out of our designated parameters. How would the creators or users of this simulation react? Would they see it as a fascinating development or as a malicious act that threatens the integrity of their construct? Our probing could be met with indifference, with curiosity, or it could prompt them to simply hit the reset button. Furthermore, if we are in a simulation, then the void beyond our universe might not be a natural phenomenon but the underlying architecture of the simulation itself, the code, the hardware, the firewall. Tampering with it could have unintended consequences that cascade through other simulations or even into the base reality, making our ethical responsibility not just to ourselves, but to beings and realities we cannot even conceive of. All of these scenarios force us to confront a deeply human tension, the relentless pursuit of knowledge versus the profound duty of stewardship. Is the universe and the meta-universe beyond it ours to explore and exploit, or are we merely temporary inhabitants, guests in a cosmos of unimaginable grandeur, with a responsibility to leave it as we found it? This is not just a scientific question, it is a philosophical and spiritual one that gets to the very heart of what it means to be a conscious species. The intercosmic silence has persisted for eternity. It is the ultimate wilderness, the last untouched place. To venture into it is an act of incredible audacity. We must decide if we are entering as respectful explorers, mindful of the sacred mystery we are engaging with, or as conquerors, driven solely by the belief that everything that can be known must be known, regardless of the cost. The shadows we seek to illuminate may be best left undisturbed, not out of fear, but out of a newfound maturity, a recognition that some mysteries are meant to be preserved, and that true wisdom lies in knowing where to draw the line. While physicists and philosophers wrestle with the void's abstract nature, its profound influence has seeped into the very bloodstream of our culture, shaping art, entertainment, and even our daily lives in ways we often don't consciously recognize. This isn't a niche fascination, it's a collective grappling with the unknown, a way for society to process the awe and anxiety of our place in an incomprehensibly vast cosmos. The void has become a powerful muse, a blank canvas onto which we project our deepest hopes, fears, and creative impulses, transforming the intercosmic silence from an abstract theory into a tangible force in our shared imagination. Consider the realm of cinema, where directors use the sheer visual and auditory power of the void to evoke emotions that dialogue alone cannot reach. Christopher Nolan's Interstellar is a masterclass in this. The film doesn't just talk about black holes and distant galaxies, it forces the audience to feel their immense, silent presence. Remember the terrifying sequence near the planet Miller, where the massive wave looms against the backdrop of a black hole, gargantua, silently dominating the sky. The sound design here is crucial. The dialogue cuts out, replaced by the overwhelming rush of water and Hans Zimmer's haunting, organ-driven score. This isn't just for dramatic effect, it's a sensory simulation of the void's oppressive power and sublime beauty, making the audience viscerally experience the isolation and wonder of deep space. It's a feeling echoed in the silent, spinning docking scene, a ballet of desperation set against the infinite black. These moments do more than advance the plot. They embed a feeling of the cosmic void into popular consciousness, making a complex scientific concept accessible through raw emotion. Beyond the blockbuster, artists have dedicated their entire careers to crafting experiences that mimic the void's disorienting and transformative qualities. Light and space artist James Turrell creates installations that are, in essence, portals to perceived infinity. When you step into one of his skyspaces or Ganzfeld pieces, something remarkable happens. The edges of the room seem to dissolve, and you are immersed in a pure, radiant field of color with no discernible depth or boundary. It's a manufactured emptiness that tricks the brain, creating a profound sense of weightlessness and contemplation. Turrell isn't painting a picture of space. He's using light itself as a material to sculpt perception, to create a void you can step inside. This artistic exploration directly mirrors our scientific journey, using sensory deprivation to evoke the same feelings of awe and existential reflection that cosmologists describe. It's a quiet, gallery-based echo of the vast, intercosmic silence, proving that the void's influence isn't confined to science fiction. It's a potent subject for the most serious fine art. This desire to not just see but to actively inhabit the void has found its ultimate expression in the interactive world of video games. Titles like No Man's Sky and Elite Dangerous offer players not a tightly scripted narrative but an entire galaxy, or even universe, to explore. The core gameplay loop is often one of solitary exploration, of jumping from one star system to the next, spending vast amounts of time traversing the empty space between planets. The genius of these games is their embrace of this emptiness. The silence between the stars isn't a flaw, it's a feature. It's in these long, quiet moments, with only the hum of your ship's engine and the hypnotic pull of a hyperdrive tunnel, that players can genuinely feel the scale and solitude of the cosmos. These games become digital meditation chambers, allowing millions of people to safely experience the emotional texture of the void, to confront the same sense of smallness and wonder from the comfort of their homes. They are powerful, popular simulators for the existential questions we've been exploring throughout this entire journey. The aesthetic of the void has even begun to shape the physical spaces we inhabit and the technology we use. In architecture, the principle of Ma in Japanese design, which emphasizes the dynamic emptiness between structural elements, creates buildings that feel open, calm, and expansive. Think of a minimalist home with vast, empty walls and open sightlines. It uses negative space to evoke a feeling of tranquility and order, a tiny, earthly echo of cosmic vastness. This philosophy is exploding in the realm of virtual and augmented reality. Designers of VR environments are keenly aware that a sense of presence and awe is often best achieved not by filling every pixel with detail, but by strategically using scale and emptiness. Placing a user on a virtual platform overlooking a seemingly infinite digital abyss can trigger a genuine physical reaction: vertigo, wonder, a caught breath. This isn't an accident, it's the intentional application of the void's psychological power to create more immersive and emotionally resonant experiences. The void, therefore, is not just inspiring art, it's driving innovation, teaching us how to design for human emotion on a grand scale. From the concert hall to the art gallery, from the living room console to the architect's blueprint, the concept of the intercosmic silence has transcended its scientific origins to become a fundamental part of our cultural vocabulary. It provides a shared language for expressing the inexpressible, our collective curiosity about what lies beyond, our anxiety in the face of insignificance, and our yearning for tranquility in a noisy world. This broad cultural footprint proves that our journey through these ideas is far more than an academic exercise. It is a deeply human one. The void's greatest impact may not be in the equations it inspires, but in the art it provokes and the reflections it forces upon us all, reminding everyone who gazes at a starry night that they are part of a story much larger than themselves. But if the void is the ultimate external reality, a canvas of quantum potential and higher dimensions, could it also hold the key to the most intimate internal reality we know, our own consciousness? This is perhaps the most speculative and breathtaking leap our journey invites us to take, a bridge between the cold equations of cosmology and the warm, subjective experience of being. The idea that mind and cosmos are not separate but deeply intertwined finds a surprising advocate in the renowned physicist and mathematician Sir Roger Penrose. Alongside anesthesiologist Stuart Hameroff, Penrose proposed a theory that seems ripped from the pages of science fiction, that consciousness is not a mere product of complex neural computation, but a fundamental feature of the universe, rooted in the quantum vibrations of spacetime itself. At the heart of their orchestrated objective reduction theory is a stunning proposition. Inside the neurons of our brains, specifically within structures called microtubules, quantum computations are constantly occurring. The collapse of these quantum wave functions, the moment a probability becomes a definite reality, isn't a random event, but a process orchestrated by the fundamental geometry of the universe. And where does this collapse happen? According to Penrose, it is a process tied to the very fabric of reality, a rippling in the foundational level of spacetime. In this view, every conscious thought, every glimmer of awareness, is a tiny quantum event echoing in the primitive void from which spacetime emerged. Our minds are not just in the universe, in a very real sense, is also in our minds. This radical perspective naturally leads us to an even more expansive philosophy, panpsychism. The word itself comes from the Greek pan meaning all, and psyche meaning soul or mind. It is the view that consciousness is not a rare and late-breaking phenomenon that only appeared with complex animal brains, but is a fundamental and ubiquitous property of the universe, much like mass or charge. In the same way that a single electron possesses a tiny amount of charge, perhaps even a single electron possesses a tiny amount of subjective experience, what philosophers call proto-consciousness. Of course, an electron doesn't think or feel emotions. Its experience would be unimaginably simple, a bare whisper of awareness. But when these fundamental particles combine into increasingly complex structures, atoms, molecules, neurons, brains, these tiny sparks of experience could combine and amplify into the rich, flowing stream of consciousness we all experience. Now apply this incredible idea to the intercosmic void. If consciousness is indeed a fundamental property of reality, then the void cannot be truly empty of it. The vast, silent expanses between universes would not be a dead wasteland, but a field of latent potential, a deep, quiet pool of proto-consciousness. The shadows we have wondered about are no longer just clumps of dark matter or stray quantum fields. They could be the faintest ripples in a cosmic mind, the most primitive forms of subjective experience waiting to coalesce into something more. The silence isn't an absence of signal, it is the deepest possible state of meditation, a universe-scale form of awareness so still and unified that it is beyond our comprehension. This notion that the cosmos itself might possess a form of awareness is not new. It is one of humanity's oldest spiritual intuitions, now being revisited through the lens of modern physics. From the concept of Brahman in Hindu philosophy to the logos of the ancient Greeks, many traditions have perceived the universe not as a dead machine, but as a living, conscious entity. The scientific exploration of the void allows us to engage with this idea not as mere superstition, but as a legitimate metaphysical possibility. It suggests that the journey through the intercosmic silence is not just an outward exploration of space, but an inward exploration of mind. The same nothingness that gives birth to universes might also be the ground from which consciousness springs. When we contemplate the void, we might, in a very real way, be contemplating the source of our own awareness. The outer abyss and the inner self begin to reflect one another, two facets of the same profound mystery. This doesn't provide easy answers, but it opens a breathtaking new avenue for inquiry, one where the boundaries between observer and observed, between mind and matter, between the self and the cosmos, start to dissolve into a more holistic and wondrous vision of reality. While Western science frames the void through mathematics and quantum theory, a breathtaking tapestry of human understanding is woven from threads far older and just as profound. To truly appreciate the depth of the intercosmic silence, we must journey beyond the laboratory and into the rich cosmological visions of cultures across the globe, where the void is not an empty equation but a living, breathing character in the story of existence. For the Maori people of Aotearoa or New Zealand, the universe begins not with a bang, but with a profound potentiality they call Te-Core. This is often translated as the nothingness, but that simple word fails to capture its depth. Te-Core is not a barren absence, it is a fertile nothing, a realm of pure being and becoming that exists before the world of light, form, and name. It is the great void from which the entire cosmos emerges in a sequence of progression from Te-Core to Te-Po the night, and finally into Te-Ao-Marama, the world of light. In this view, the shadows we ponder in the cosmic abyss are not ominous. They are the very source of all possibility, a creative darkness that holds the blueprint for all that is and ever will be. It is a concept that resonates powerfully with the quantum idea of a vacuum seething with virtual particles, a nothingness that is paradoxically full. This vision of the void as a generative force finds a powerful parallel in the ancient Chinese philosophical system of Taoism. Here, the concept of Wu emptiness or non-being is absolutely central to understanding reality. The Tao Te Ching, attributed to the sage Lao Tzu, constantly points to the utility of emptiness. It is the hollowed-out center of a bowl that gives it its use. It is the empty space inside a window frame that allows the light to pour through. Wu is not a void to be filled, but an active, dynamic principle that makes all action and form possible. It is the soft, yielding, and receptive counterpart to the hard and active yang. In the cosmological sense, the Tao itself, the ultimate, indefinable source of everything, is often described as a boundless, empty void from which the 10,000 things spontaneously arise. This mirrors the scientific concept of the universe emerging from a quantum fluctuation in a metastable vacuum, but it adds a layer of purposeful, natural harmony. The Chinese void is not a random accident. It is a necessary phase in a continuous, cyclical process of generation and return, where emptiness and form exist in a beautiful, eternal dance. Crossing the globe to the vast continent of Africa, we find cosmologies where the void is deeply intertwined with the spiritual world and the realm of ancestors. In many traditional African belief systems, the universe is not divided into a strict separation between the physical and the spiritual. The world of the living, the world of the dead, and the natural world are all part of a single, interconnected whole. Within this framework, the empty spaces, the deep forests, the vast deserts, the silent night sky, are often seen as liminal zones, places where the veil between worlds is thin. These voids are not empty at all. They are populated by the presence of ancestors and spirits. For instance, in some cultures, the clear night sky, which we might see as a void, is perceived as a great dome that separates the world of the living from the spiritual world beyond. The stars might be seen as the eyes of ancestors watching over their descendants, or as campfires in the spirit world. The void, therefore, becomes a sacred space for communication and connection, a dangerous but necessary frontier that must be approached with respect and ritual. It is a realm of immense power, where the shadows are not theoretical entities but the very real presence of those who came before. This stands in fascinating contrast to some pre-Columbian Mesoamerican views, where the void could also be a place of terror and chaos. For the Aztecs, the world had been created and destroyed 4 times before our current era, the fifth sun. Each destruction plunged the world back into a primordial void of darkness and chaos. Their mythology tells of the god Quetzalcoatl journeying into the underworld Mictlan to retrieve the bones of previous generations to create a new humanity. This underworld was a dark, silent, and perilous place, a void that had to be courageously traversed and overcome to bring about new life. Here, the emptiness is not a friendly potential but a threatening force of oblivion that must be constantly held at bay through ritual and sacrifice to ensure the sun continues to rise. The void is the ever-present threat of a cosmic reset, the silent enemy of order and life. Placing these diverse perspectives side by side does not diminish the scientific view, it profoundly enriches it. It shows us that the question of the void is not a new one, and that the many ways of answering it are not in competition, but in conversation. A physicist might describe the void as a quantum foam. A Maori scholar might describe it as Tikor. A Taoist master might call it Wu. These are not contradictory truths, but different languages describing the same profound mystery. Each cultural lens offers a unique way of seeing, and in doing so, it asks a different kind of question of the darkness. Science asks how the void functions. Philosophy asks what it means. Many indigenous cosmologies ask who might inhabit it and how we should relate to it. This incredible diversity of thought is not an obstacle to understanding, but the very key to it. It reminds us that our journey to comprehend the intercosmic silence is not a straight line toward a single, final answer. It is a gathering of voices from across time and space, each adding a unique verse to the grand, eternal poem humanity is composing about the stars and the silence between them. Long before we had the mathematics to model the multiverse or telescopes to peer into the deep field, writers were already charting the psychological contours of the void, using the raw materials of language and imagination to build bridges into the abyss. Literature has served as humanity's first and most intimate probe into the intercosmic silence, a tool not for measuring radiation or gravity, but for mapping the emotional and existential terrain of nothingness itself. This tradition stretches back to the 19th century, to the brilliant and troubled mind of Edgar Allan Poe. In his final work, the prose poem Eureka, Poe ventured far beyond his usual Gothic haunts to present a startlingly prescient cosmological vision. He described a universe that began from a single, primordial particle and would eventually collapse back into oneness, all set against an infinite and eternal void that served as both its canvas and its eventual tomb. For Poe, this nothingness was not just a scientific reality, but a source of profound aesthetic and spiritual terror. He understood that the true horror of the cosmos wasn't found in ghosts or ghouls, but in the sheer, silent, indifferent scale of it all, a realization that would become the bedrock of a new literary genre. This nascent dread blossomed fully in the 20th century with the rise of cosmic horror, a mode of storytelling where the void itself is the primary antagonist. While H.P. Lovecraft is its most famous architect, his ideas found a more refined and chilling expression in the work of authors who followed. Arthur C. Clarke, a trained physicist as well as a master storyteller, wielded the void with a unique clinical precision. In his novel The City and the Stars, he doesn't merely describe the space between galaxies, he makes you feel its weight. He follows a spaceship on a million-year journey across the gulf between star systems, a voyage so long that the very concept of human purpose begins to unravel. Clarke uses the vast, empty distances not as a backdrop for action, but as an active force that grinds down ambition and redefines eternity. The silence his characters confront is the silence of a universe that does not care, a theme he would later perfect in the stark, awe-inspiring finale of 2001, A Space Odyssey, where the monoliths stand as silent, enigmatic sentinels in the void, their meaning forever beyond human grasp. The literary exploration of nothingness took a more intimate and philosophical turn with the short stories of Ted Chiang. In works like Exhalation, Chiang performs a breathtaking feat. He makes the reader care deeply about the existential plight of beings in a universe that is literally running out of air. The story is narrated by a mechanical creature in a sealed world who discovers that their atmosphere is slowly equalizing with the vacuum outside, leading to an inevitable, silent end. Chiang's genius lies in using this slow-motion apocalypse to explore the nature of consciousness, memory, and the second law of thermodynamics. The void in his story is not a distant threat. It is a patient, inevitable presence, the ultimate equilibrium. The prose itself becomes a metaphor for this entropic fade, often calm and methodical even as it describes the end of everything. Chiang demonstrates that the most powerful way to convey the cosmic silence is not through grand, booming declarations, but through the quiet, meticulous observation of its inevitable creep into every corner of existence. So how do writers who work with words convey the essence of wordless nothing? They employ a sophisticated toolkit of literary techniques designed to evoke absence. One of the most powerful is the use of negative space in prose itself. This can mean long, sprawling sentences that describe immense, empty landscapes, forcing the reader's eye to travel a great distance across the page to mimic a journey through space. It can also mean the strategic use of silence within the narrative pauses in dialogue, chapters that end not with a climax but with a fade to black, or moments where a character simply listens to the overwhelming nothing and the reader listens with them. Another potent technique is the metaphor of absence. Authors will describe the void not by what it is, but by what it lacks. They talk about the cold that is not merely an absence of heat, but a positive, biting force. They describe the blackness not as a lack of light, but as a substance, a velvet nothing that presses in on the ship's hull. This linguistic trickery allows our brains to conceptualize the unconceptualizable by framing it in terms of tangible things we understand and fear losing. Through these narratives, the intercosmic silence becomes far more than a setting. It becomes the ultimate crucible for the human spirit. It is the place where all our grandest themes, isolation, hope, curiosity, and despair are boiled down to their purest forms. A character alone in a life pod drifting between stars is the most absolute representation of isolation possible. Their hope for rescue is a tiny, fragile flame against an infinity of dark, and their curiosity about what lies beyond is the very engine of the story, the undeniable human impulse that pushes them deeper into the unknown even when every survival instinct screams to turn back. Literature allows us to live inside that paradox, to feel both the paralyzing terror and the sublime wonder of the void from the safety of our own minds. It answers the scientific what if with the deeply human what would it feel like. This rich artistic engagement does not compete with our scientific journey, it completes it. Science gives us the equations and the evidence, the magnificent how of the cosmos. But literature gives us the meaning. It provides the emotional and philosophical context for the cold, hard data, transforming the cosmological void from an abstract concept into a lived experience. It reminds us that every datum from a deep space telescope, every theory about quantum foam, is ultimately a story told by a conscious mind trying to find its place in a vast and silent universe. The writer and the physicist are fellow travelers on the same road, one charting the map of external reality, the other drawing the detailed landscape of the internal human response to that reality. Together, they ensure that our conversation with the void is not a monologue of facts, but a dialogue that encompasses all of what we are: the rational and the emotional, the calculating and the curious, forever reaching into the darkness not just with instruments but with our souls. But if the void is an impassable barrier forever isolating islands of reality, then what are we to make of one of the most bizarre and well-tested phenomena in all of physics: quantum entanglement? This strange property, which Albert Einstein himself famously dismissed as spooky action at a distance, describes a situation where two particles become inextricably linked, their fates intertwined no matter how far apart they are separated. Change the property of one like its spin or polarization, and its partner instantaneously responds, mirroring that change. This connection seems to defy the cosmic speed limit set by light, operating faster than any signal could possibly travel between them. For decades, this was seen as a fascinating but isolated quantum quirk, a puzzle confined to the laboratory. But a revolutionary idea is now emerging from the frontiers of theoretical physics, one that suggests this spooky link might not be confined by distance at all. It might not even be confined by the boundaries of our universe. This raises a staggering possibility. Could the strange, silent void between universes be secretly threaded with these quantum connections, creating a hidden network that binds the multiverse together? This breathtaking idea is crystallized in a theory known by the deceptively simple equation ER=EPR, proposed by physicists Juan Maldaisner and Leonard Susskind. This concept is a masterpiece of theoretical synthesis. It boldly connects two of Einstein's greatest contributions, which were previously thought to be entirely separate. The ER part of the equation refers to the Einstein-Rosen bridge, better known as a wormhole, a theoretical tunnel through spacetime that could, in principle, create a shortcut between two distant points. The EPR part refers to the Einstein-Podolsky-Rosen paradox, the very thought experiment that first highlighted the bizarre implications of quantum entanglement. The theory suggests that these two concepts, one from general relativity and one from quantum mechanics, are not just analogous, they might be two different descriptions of the exact same thing. In other words, every pair of entangled particles might be connected by a microscopic wormhole, a tiny bridge in the fabric of spacetime itself. The spooky action at a distance isn't spooky at all. It's a direct communication through a hidden geometric tunnel that we simply cannot perceive. Now, let your imagination follow the implications of this idea to their logical and truly cosmic conclusion. If entanglement is indeed physically manifested as these spacetime bridges, and if the quantum connection can persist across any distance within our universe, what is to stop it from reaching further? If our universe is just one bubble in a vast multiverse foam, could these microscopic wormholes thread through the intercosmic void, connecting particles in our universe to their entangled partners in a completely different reality? The void, in this view, would be far from empty. It would be a labyrinth of unimaginable complexity, woven through with an uncountable number of these quantum threads, each one a whisper of connection between islands of existence that are otherwise forever separated by an ocean of silent, expanding space. The shadows we sense in the darkness might not be isolated phenomena. They could be the faint, gravitational echoes of these bridges, the subtle warping of space-time by connections that transcend the classical limits of reality. This transforms our understanding of the void from a barrier into a potential conduit. The profound silence that has defined our cosmic loneliness might not be absolute. It could be more like a dense fog that prevents us from seeing the other ships, even though we are all connected by an intricate web of invisible lines. We cannot shout across the gulf, but we might be able to feel a tug on the line. The implications for communication are, of course, the stuff of science fiction. If we could learn to control and manipulate these entangled links that might span the multiverse, we could theoretically send information not by broadcasting a signal through the void, but by tweaking our end of the connection and having that change instantly reflected on the other side, no matter how distant. This wouldn't violate the speed of light because no information is actually traveling across the space between. It's appearing simultaneously at both ends of the wormhole bridge. The void becomes irrelevant to the conversation. However, before we get too carried away with visions of multiversal messaging, we must confront the immense practical challenges. Even if ER equals EPR is correct, these wormholes are thought to be incredibly unstable, pinpricks in spacetime that would snap shut in an instant. Keeping one open long enough and enlarging it enough for anything, even a single photon, to reliably pass through would require types of matter and energy that we have never seen exotic matter with negative energy density. Furthermore, while entanglement allows for instantaneous correlation, it does not allow us to send a controlled, meaningful message in the way we normally think of it. You can't force a specific outcome on your end. You can only observe the random outcome and know that your partner will see the correlated result. Using it for communication would require a level of control over quantum states that is far beyond our current capabilities. So, while the theory offers a stunningly beautiful mechanism for connection, it does not provide an easy switchboard for calling other universes. Yet, the true power of this idea may not be in practical communication, but in its profound philosophical implications. It suggests that the cosmos, at its most fundamental level, is deeply and inherently interconnected. The separateness we experience, the vast distances between stars, the even vaster voids between galaxies, and the seemingly unbridgeable gulfs between universes might be an illusion, a feature of our limited classical perspective. At the quantum level, the multiverse might be a single, unified, and entangled whole. The shadows in the void are not lonely outposts. They are distant nodes in a cosmic network, participants in a grand, silent dance of correlation that has been ongoing since the first moment of creation. This doesn't make the cosmos feel smaller, but it makes it feel profoundly more intimate. We are not isolated prisoners in a solitary cell. We are integral parts of a connected reality, our existence subtly but surely linked to everything else, even that which lies in the silent darkness beyond our horizon. It is a glimpse of a universe that is not lonely but whole. Yet after mapping the quantum threads that might weave through the nothingness, we arrive at a profound and deeply human realization. The void is not merely a subject for equations or philosophical debate, but a wellspring of profound beauty. This aesthetic dimension transforms our journey from an intellectual exercise into a sensory experience, revealing that our fascination with emptiness is as much about feeling as it is about knowing. Across cultures and centuries, artists and designers have understood that what is left out is just as important as what is put in, that the spaces between notes create the music, and that the silent pauses give weight to our words. This conscious embrace of nothingness is perhaps nowhere more refined than in the principles of Japanese aesthetics, particularly in the concept of ma. Ma does not simply mean empty space. It signifies a dynamic, purposeful interval that gives form its meaning and breath its rhythm. It is the charged pause in a conversation, the careful gap between stepping stones in a Zen garden that forces mindful presence with each step. In a traditional ink wash painting, the vast, untouched portions of the scroll are not an unfinished background. They are active elements. They might be mist, water, or sky, their meaning shaped by the brushstrokes that border them. The void is not an absence to be filled, but a presence to be felt, a silent partner in a delicate dance with form. This reverence for the empty and the open finds a stunning modern expression in the work of the French artist Yves Klein. In the 1950s, Klein became obsessed with the void as a creative concept, going so far as to stage an exhibition called The Void, which featured an entirely empty gallery. But his most famous contribution was his development and patent of International Klein Blue, a mesmerizing ultramarine pigment that he used to create monochrome paintings of breathtaking depth. Klein wasn't just applying blue paint, he was attempting to capture the void itself. He saw this intense, spiritual blue as a portal to the immaterial, a color that could evoke the infinite expanse of the sky and the sea. When you stand before one of his large blue canvases, the effect is not of looking at a flat surface, but of falling into a boundless space. The color saturates your vision, eliminating all visual noise and inviting a state of contemplative trance. Klein's work demonstrates that the void is not a neutral emptiness. It can be an intense, almost overwhelming sensory experience, a blast of pure potential that overwhelms the senses to clear a path for a deeper, more intuitive understanding. This power of the void to evoke emotion is masterfully harnessed in cinema through the deliberate use of silence. A film's soundtrack is not just music and dialogue, it is a carefully constructed soundscape, and the strategic removal of sound can be its most powerful tool. Think of the profound moments in Stanley Kubrick's 2001, A Space Odyssey, when all we hear is the slow, rhythmic breathing of an astronaut set against the utter silence of deep space. That silence is not an audio error, it is a visceral, gut-level communication of absolute isolation and the terrifying grandeur of the cosmos. It makes the vastness feel real and immediate. Similarly, in Alfonso Cuarón's Gravity, the silence of space is a constant, menacing character. The film often drops all sound except the character's panicked breaths when outside the spacecraft, plunging the audience into her disorienting and deadly reality. The absence of sound creates a palpable tension and awe that no orchestral score could ever achieve. It is a direct auditory analogy for the intercosmic silence, a profound nothing that is felt more powerfully than any something. Photography, too, has long held a romance with the aesthetics of emptiness. The genre of minimalist photography proves that a compelling image can be built around a single subject surrounded by vast, negative space. A lone tree in a foggy field, a small boat on a calm sea at dawn, a single window in a vast, blank wall. These compositions use emptiness to create a mood of tranquility, loneliness, or sublime peace. The emptiness focuses the eye and the mind, directing our attention not just to the object, but to the space around it, forcing us to contemplate the relationship between the two. The great landscape photographers of the American West, like Ansel Adams, often use the vast, empty skies and sweeping deserts not just as a backdrop, but as the emotional core of their images, conveying a sense of scale that is both humbling and beautiful. They teach us to see the beauty in the barren, the majesty in the minimal. This artistic engagement with the void completes our journey in a deeply emotional way. Science gives us the what and the how, philosophy gives us the why, but art gives us the feel. It translates the cold, abstract concept of intercosmic silence into something we can experience in our bodies and our hearts. It shows us that the human response to nothingness is not solely one of fear or existential dread, but can also be one of profound peace, awe-struck wonder, and deep aesthetic appreciation. The shadows we have been pondering, those theoretical entities and distant universes, are not just puzzles to be solved. Through the lens of art, they become subjects of beauty, their mystery as alluring as their explanation. The silent void between the stars is not just a scientific frontier, it is the ultimate canvas, and we are the artists, forever trying to capture its impossible, beautiful darkness with the tools we have: pigment, light, sound, and the boundless human imagination. But if the void is a realm where the very laws of physics may break down, then what becomes of time itself within that absolute nothingness? Our entire experience of reality is built upon the steady, irreversible flow of time, the past that shapes us, the present we inhabit, and the future we anticipate. Yet this arrow of time, this relentless forward march, might not be a fundamental feature of the cosmos. It could be an emergent property, a side effect born from the specific conditions within our universe. And in the pristine, featureless expanse of the true intercosmic void, where there is no matter, no energy, and no discernible structure, time as we know it could simply cease to have any meaning whatsoever. This radical idea finds a compelling champion in the physicist Julian Barber, who has spent decades arguing that time is in fact an illusion. In his view, the universe is not a movie playing out frame by frame, but a vast collection of every possible configuration of particles, what he calls nows. Each now is a frozen snapshot of the entire cosmos, a single moment in which everything, arranged in a specific way. What we perceive as the flow of time, Barber suggests, is merely our consciousness moving through this infinite landscape of nows, creating a narrative from a sequence of static states. There is no past flowing into a future, there is only an eternal, timeless landscape of possibility. Now, project this captivating idea onto the intercosmic void. If time is an illusion within our bustling universe, how much more so must it be in a realm of pure nothingness? The void would be the ultimate expression of Barber's timelessness, a place with no configurations, no particles, no changes to mark the passage from one now to another. It is a state of pure being without becoming. The silence there isn't just an absence of sound, it is an absence of sequence, a perfect stillness where the concepts of before and after dissolve into irrelevance. This challenges one of our most deeply held physical laws, the second law of thermodynamics, which gives us the arrow of time through the relentless increase of entropy. In our universe, we know time is moving forward because disorder always increases. Milk mixes into coffee but never unmixes, and we remember the past but not the future. This growing disorder provides the universe with a built-in direction, but entropy requires a system. It requires particles to become disordered, energy to spread out. The true void, by its very definition, has no such system. It is the state of maximum possible entropy, a perfect, uniform equilibrium where nothing can happen because there is no gradient, no difference, no potential for any further change. In this state of ultimate balance, the arrow of time has nowhere to point. It simply vanishes. The void, therefore, might not be a place that exists in time, but a place that exists entirely outside of it, an eternal now that surrounds the temporary, time-bound dramas of bubble universes like our own. The bizarre rules of quantum mechanics add another layer of profound strangeness to this timelessness. In the quantum world, at the very smallest scales, the distinction between cause and effect becomes fuzzy. Particles can briefly exist in a state of superposition, influencing each other in ways that are not clearly bound by a linear sequence of events. This has led some physicists to speculate that on a fundamental level, the universe might not strictly obey causality, the law that cause must always precede effect. In our everyday world, this quantum weirdness is washed out by the sheer number of particles interacting. But in the near-perfect emptiness of a vast cosmic void, or especially in the absolute purity of the intercosmic void, these quantum effects could dominate. Without the decohering influence of matter and energy, the quantum foam could become a realm of pure potentiality, where events are not ordered in a timeline but exist in a tangled web of possibility. An effect in one region could theoretically influence its cause in another, or they could simply arise together, connected not by time but by quantum correlation. In such a place, the very foundation of narrative reality, that this happened which led to that, would completely break down. So what does this mean for the shadows we imagine lingering in this silent expanse? If the void is a timeless realm, then the entities within it cannot be understood as static objects frozen in place. They must be something far more strange. They could be fluctuations in time itself. Imagine an echo without an original sound, a ripple in the fabric of causality that has no clear point of origin. A shadow in the void might be the ghost of an event that never actually occurred in a linear timeline, a possibility that briefly flickered into a kind of reality within the quantum foam before fading back into the background noise of nothingness. Or it could be an eternal object, a structure whose existence is not spread out over time, but is entirely whole and complete in a single, timeless instant. To perceive such a thing would be to see its entire history and its future all at once, a concept that is utterly incompressible to our time-bound brains. This temporal perspective forces us to see the void not as a blank slate, but as a palimpsest written in a language without verbs. It is a realm where the most fundamental building blocks of our experience are absent, making it the ultimate enigma. Our journey through the intercosmic silence becomes not just a voyage through space, but a voyage beyond the very dimension that structures our consciousness. The shadows there are not just hidden in the dark, they are hidden in time, or more accurately, from time. They are the permanent residents of a realm without change, without history, and without future, making them the most alien and profound mysteries we could ever hope to encounter. Yet after exploring the timeless, quantum-weird nature of the void, we are faced with a monumental challenge. How can the human mind, bound by language and sensory experience, possibly hope to describe the indescribable? The answer lies in the most powerful and abstract tool we have ever devised, a language that exists beyond words: mathematics. While our everyday vocabulary fails utterly in the face of absolute nothingness, mathematics provides a formal, precise syntax for grappling with the void, transforming it from a terrifying philosophical abyss into a structured space of inquiry that can be mapped, measured, and modeled. It is the only lens sharp enough to bring the faintest shadows of the intercosmic silence into any kind of focus. This process begins with the simplest of mathematical concepts, the empty set. In set theory, the foundation of modern mathematics, the empty set is the unique set that contains no elements. It is denoted by the symbol or. While it seems trivial, this concept of a collection with nothing in it is a profound first step. It allows mathematicians to define nothingness not as an absence of things, but as a specific, well-defined object with its own properties and relationships to other sets. The empty set is the starting point for building all of mathematics. It is the substrate from which numbers and all higher structures logically emerge. This mirrors the cosmological idea of the void as a generative nothingness, a foundational state from which the entire universe of something can potentially arise. The empty set is the mathematical analog of the primordial void, a precise, formalized nothing that is absolutely necessary for everything else to exist. As we move from the abstract foundations to the physics of the real world, mathematics provides ever more sophisticated tools to describe emptiness. Albert Einstein's field equations for general relativity are a stunning example. These deceptively compact lines of tensor calculus do not just describe how matter and energy warp spacetime. They also provide a complete description of completely empty spacetime itself, a perfect vacuum. The solutions to these equations in the absence of matter give us models of the void, from the flat, unchanging emptiness of Minkowski space to the wildly curved and dynamic spacetime around a black hole. In quantum mechanics, the picture gets even stranger. The vacuum state is not described as simple emptiness, but as a complex object in an abstract mathematical space called a Hilbert space. This framework allows physicists to represent the seething quantum foam, a vacuum teeming with virtual particles and fluctuating energy, with rigorous precision. The mathematics doesn't just describe the void, it reveals a void far richer and more active than our intuition could ever suggest. The challenge of the multiverse and higher dimensions pushes mathematical language to its absolute limits. This is where the pioneering work of a 19th-century mathematician named Georg Cantor becomes shockingly relevant. Cantor dedicated his life to understanding the nature of infinity, a concept as abstract and mind-bending as the void itself. He discovered that infinity is not a single, monolithic idea. There are different sizes of infinity. He proved that the infinity of real numbers is vastly larger than the infinity of whole numbers, a revolutionary and controversial idea at the time. Cantor's hierarchy of infinities provides the essential language for discussing a multiverse. If the multiverse is truly infinite, what kind of infinity is it? How many different types of universes could it contain? Cantor's work allows cosmologists to ask these questions with mathematical rigor, providing a framework to discuss whether all possible universes actually exist somewhere in the meta-void, or if there are limitations even on an infinite scale. For the even more exotic idea of higher dimensional voids from string theory, mathematicians turn to the field of topology. Topology is often called rubber sheet geometry. It is the study of the properties of space that remain unchanged under continuous stretching and bending. A topologist doesn't care about distance or angles, but about more fundamental properties like connectedness and the number of holes an object has. This makes it the perfect tool for modeling the higher dimensional voids of the string theory landscape. Topologists can describe the intricate, curled-up shapes of the extra dimensions and how they might connect different regions of the meta-universe. They can model hypothetical structures like wormholes, topological tunnels through spacetime that could, in theory, provide a passage through the void. This mathematical language allows physicists to describe realms with 10 or 11 dimensions, spaces that are utterly unimaginable to our three-dimensional brains, but which can be navigated with the compass of abstract mathematics. Yet for all its breathtaking power, mathematics itself may ultimately hit a wall when confronted by the true void. In the 1930s, logician Kurt Gödel delivered a devastating blow to the dream of a complete mathematical system with his incompleteness theorems. He proved that in any sufficiently powerful axiomatic system, there will always be true statements that cannot be proven within that system. The system cannot prove its own consistency. This profound result suggests an inherent limitation in formal mathematics. There may be aspects of reality, especially a reality as fundamental and strange as the primordial void, that are literally uncomputable or undefinable. They might be true, but we could never prove them with logical deduction from a set of axioms. The void might contain truths that are forever beyond the reach of any formal description, residing in a realm of mystery that logic can point to but never fully encapsulate. This creates a beautiful and humbling duality in our quest. Our journey to understand the intercosmic silence is both rigorously rational and deeply intuitive. We rely on the cold, hard logic of mathematics to build our models and make our predictions, to illuminate the shadows with the precise light of numbers. Yet, we must also acknowledge that those shadows may never be fully dispelled. The mystery is not a temporary obstacle to be overcome by better math. It may be a permanent feature of the cosmos, an essential frontier between what can be known and what must be wondered at. Mathematics, therefore, does not eliminate the awe. It gives that awe a structure and a language. It allows us to stand at the edge of the abyss and not just feel terror, but to engage in a profound conversation with it, using the most powerful language we know to ask questions of the silence, even if the final answers forever elude our grasp. Yet, even as we chart the quantum threads and mathematical models that might structure the void, we must turn to a language far older than calculus or physics, the language of faith and spirit. For millennia, long before telescopes peered into the abyss, religions and spiritual traditions across the globe have been grappling with the concept of nothingness, not as a terrifying emptiness, but as the most sacred ground of all being. This spiritual encounter with the void offers a profound counterpoint to our scientific journey, suggesting that the intercosmic silence might not be a mere absence to be explained, but a divine presence to be experienced. In the Christian tradition, the foundational concept of creatio ex nihilo, creation out of nothing, places the void at the very heart of divinity. This is not the passive nothingness of a blank slate, but an active, generative nothingness that only God can command. Before the beginning, there was no pre-existing material, no chaotic plasma. There was only the absolute, transcendent God, and from His will alone, the entire cosmos was spoken into existence. The void here is the ultimate demonstration of divine omnipotence, the sheer power to bring forth everything from absolutely nothing. This theological idea resonates strangely with our modern quantum insights, where particles flicker in and out of the vacuum, but it frames that nothingness as an expression of a conscious, loving will rather than a random fluctuation. The silence between the stars in this view is not an accident. It is the enduring echo of that first divine fiat, the lingering breath of a creator who needs no raw materials to work his art. This pursuit of divine nothingness finds one of its most sophisticated expressions in the ancient practice of apophatic theology, or the via negativa. Found in Christianity, Judaism, and Islam, this is a path to understanding God not by what He is, but by what He is not. Since God is infinite and utterly transcendent, all human language and concepts are ultimately inadequate to describe Him. Thinkers like Pseudo-Dionysius the Areopagite and Meister Eckhart argued that we approach closest to the divine not by building up images and ideas, but by systematically stripping them all away. We must let go of goodness, power, wisdom, even being itself, until we are left in a state of profound ignorance, a blissful darkness where the soul encounters God beyond all concepts. This inner void of the mind becomes the meeting place with the ultimate reality. The practice is a spiritual mirror of the cosmic void, both are realms where our ordinary categories of understanding fail, and we are left in a silent, awe-filled encounter with something infinitely greater than ourselves. The external emptiness of space and the internal emptiness of the soul become two paths leading to the same ineffable mystery. On the other side of the world, this intuitive understanding of emptiness as a path to enlightenment is developed with breathtaking precision in Buddhism. The core concept of sunyata, or emptiness, is perhaps the most profound and frequently misunderstood principle in all of spiritual thought. It does not mean that things do not exist or that the world is an illusion. Instead, it refers to the liberating realization that nothing possesses an independent, permanent self or essence. Everything that exists from a distant galaxy to the self that observes it arises only in dependence upon a vast web of causes and conditions. A galaxy is not a solitary, solid thing. It is a temporary gathering of stars, gas, and dark matter, all held in a delicate dance by gravity, itself a manifestation of curved spacetime. To see the world as empty is to see its true nature of radical interdependence and constant flux. This realization is not a nihilistic end but a joyful beginning, a release from the suffering that comes from clinging to the illusion of permanence and separateness. The great intercosmic silence from this perspective is the ultimate expression of sunyata. It is not a barren wasteland but a field of infinite potential relation, a vast openness that allows all forms to momentarily arise, play their part, and dissolve back into the whole. The shadows we project onto it are our own clinging to form. The reality is a luminous, interconnected whole. These profound theological and philosophical traditions are not merely abstract beliefs. They are made tangible through dedicated spiritual practices designed to help the practitioner directly experience this sacred nothingness. Meditation, in its countless forms across traditions, is essentially the intentional cultivation of inner silence. Whether it's the Christian hesychast repeating the Jesus prayer to achieve a state of quiet stillness, the Zen Buddhist sitting in zazen to let go of all discursive thought, or the mindfulness practitioner simply observing the breath, the goal is similar: to quiet the constant chatter of the mind and touch a deeper, more fundamental layer of awareness beneath it. In this state, the meditator might experience a profound sense of peace, a dissolving of the ego's boundaries, or a feeling of merging with a greater whole. This inner silence is the personal, experiential correlate to the cosmic silence. It is as if each human consciousness contains its own miniature void, a quiet center that mirrors the vast expanse between the stars. By journeying inward into this personal silence, we gain an intuitive, non-conceptual understanding of the void that complements the intellectual understanding offered by science. We don't just think about nothingness, we feel it. These spiritual perspectives collectively offer a radical reinterpretation of the shadows we have been wondering about in the intercosmic darkness. Science asks what the shadows are made of and how they came to be. Religion and spirituality suggest a different question: could the shadows be sacred? Could the apparent emptiness be, in fact, a plenum of divine presence? Could the silence be the sound of God's ongoing creation, the Buddha's smiling silence, or the Brahman that is both the source and substance of all reality? This is not a proposition that science can confirm or deny, as it operates in a different domain of human experience, the domain of meaning, value, and ultimate purpose. By including these voices in our journey, we do not abandon rationality. We expand our conversation to encompass the full human response to the cosmos. We acknowledge that our drive to understand the void is driven not only by curiosity, but by a deep, innate yearning to know our place in the universe and to connect with whatever ultimate reality may underpin it. The quest to understand the intercosmic silence, therefore, becomes the most holistic of human endeavors, a journey that requires both the precision of the physicist's equations and the open heart of the mystic in meditation, for both are needed to fully appreciate the profound and mysterious darkness from which we all emerge. But perhaps the most profound confrontation with the void is not found in the stars above, but in the quiet moments of our own lives. This brings us to a deeply personal dimension of our journey, one that shifts our gaze from the infinite cosmos to the intimate depths of the self. Existential philosophy, a movement born from the trembling ashes of world wars and the collapse of old certainties, argues that it is precisely by staring into the abyss, by confronting the sheer nothingness that underpins existence, that we truly discover who we are. Thinkers from Soren Kierkegaard to Jean-Paul Sartre proposed that human identity is not a fixed, pre-written script. Instead, it is something we forge ourselves moment by moment through our choices and actions. And there is no greater catalyst for this act of self-creation than the dizzying realization that we are temporary, fragile beings adrift in a silent, seemingly indifferent universe. The intercosmic silence we have been exploring is not just a physical reality, it is the ultimate metaphor for this existential groundlessness. When we ponder those vast, dark stretches between galaxies and universes, we are holding up a mirror to the fundamental uncertainty within our own lives. That external emptiness reflects our internal questions about purpose, mortality, and whether our brief, flickering lives hold any significance at all. The 20th century philosopher Albert Camus framed this confrontation with stark and powerful clarity. He began with what he called the absurd, the painful conflict between our deep, human craving for meaning, order, and answers, and the complete, utter silence and indifference the universe offers in return. We are beings who need meaning, born into a world that offers none. For Camus, this was not a problem to be solved but a fact to be acknowledged, the fundamental condition of human life. He famously imagined the myth of Sisyphus, condemned by the gods to eternally push a boulder up a mountain, only to watch it roll back down each time he neared the top. This is the epitome of a meaningless, futile task. And yet, Camus concludes that we must imagine Sisyphus happy. His radical proposition is that the only authentic response to the absurd is to embrace the struggle itself. To find joy and defiance not in reaching a final meaning, but in the act of pushing the boulder, in the sheer persistence of living and creating in the face of a silent cosmos. The void does not give us meaning, it gives us the breathtaking freedom and responsibility to create our own. Every act of love, every work of art, every moment of compassion becomes a deliberate act of rebellion against the nothingness, a way of saying, I am here, into the silent dark. This philosophical stance transforms the shadows we have been wondering about in the intercosmic silence from distant cosmic anomalies into something deeply personal. Those theoretical entities, the rogue planets, the quantum fluctuations, the dark matter structures become more than just scientific curiosities. They become symbols. They represent the unknown, not just out there, but within us. They are the parts of our own psyche we have yet to understand, the fears we haven't faced, the potential we haven't unlocked. The journey to map the cosmic void is, in a very real sense, a parallel journey to map the interior void of our own consciousness. Just as cosmologists use telescopes and equations to bring light to the dark corners of the universe, we use introspection, art, and relationships to bring light to the dark corners of ourselves. This quest for self-discovery is driven by the same engine as our quest for cosmic discovery, a fundamental curiosity about the nature of the reality we inhabit. By engaging with the greatest external mystery, we are inevitably compelled to engage with the greatest internal one. The silence between the stars urges us to listen to the silence within, and in doing so, we often find that the two are intimately connected. This introspective turn does not diminish the scientific wonder of our exploration. It amplifies it by adding a layer of profound human relevance. It reminds us that we are not separate observers of the cosmos, but are woven from its very fabric. The carbon in our cells was forged in the hearts of long-dead stars. The laws of physics that govern the expansion of the universe also govern the electrical impulses in our brains. When we study the void, we are in a way studying our own origins and our own ultimate fate. This realization can be terrifying, triggering what philosophers call existential anxiety, a deep unease about our fragility and smallness. But it can also be incredibly empowering. It places us squarely in the center of a magnificent, unfolding story. Our awareness is the universe's way of knowing itself. Our questions, our art, our science, and our love are the means by which a silent cosmos finds a voice. We are the universe become conscious, and in our struggle to find meaning, the universe finds meaning through us. So the next time you look up at a clear, star-filled night sky, feel the awe, but also feel the connection. That vast, beautiful emptiness is not just something to be observed. It is a part of who you are, an invitation to create, to explore, and to define your own place in the grand and silent scheme of things. And it is within this profound silence, this canvas of infinite potential, that we discover one of the void's most surprising and powerful gifts, its role as the ultimate muse for human creativity. This is not a metaphorical stretch. It is a direct parallel to the very way innovation works within our own minds. Consider the writer facing the daunting blank page, or the designer staring at an empty canvas. That initial emptiness is not a barrier. It is the essential starting condition for all creation. It is a space free of preconceptions, a silent void that must be filled with something new. This blank page technique is a cornerstone of creative theory because it forces a breakthrough, a leap from nothing to something. In the same way, the vast, intercosmic silence represents the ultimate blank page for the scientific and engineering mind. It is the great unknown that refuses to be ignored, a perpetual question mark that demands an answer, a puzzle that ignites our deepest inventive instincts. This creative dynamic is perfectly illustrated by the artistic principle of negative space. A skilled artist does not just focus on the object they are drawing, they pay exquisite attention to the empty space around it. It is this careful management of the void, the gaps between branches, the shape of the sky around a mountain, that actually defines the form and gives the composition its balance and power. The void is not passive, it is an active element of the art. Science operates on the same principle. Our entire scientific endeavor is built upon the negative space of the unknown. Every equation, every theory, is a shape we draw against the vast, dark background of what we do not yet understand. The mysteries of the intercosmic void, the nature of dark energy, the possibility of other dimensions, the puzzle of quantum gravity, are not just gaps in our knowledge. They are the negative space that gives shape and direction to our research, the silent partner in a dance of discovery that pushes us to imagine beyond the limits of the known. This relentless drive to fill the negative space has directly catalyzed some of our most ambitious technological dreams. The concept of the void itself has become an engineering challenge. How would we traverse it? This question has propelled the development of theoretical propulsion systems that sound like pure science fiction, yet are grounded in real physics. Concepts like the Alcubierre warp drive, which proposes contracting spacetime in front of a spacecraft and expanding it behind, are a direct response to the void's immense scale. While harnessing the necessary energy remains a monumental hurdle, the very act of mathematically modeling such a drive is a triumph of creativity inspired by emptiness. Similarly, the existential challenge of protecting humans in the absolute void has spurred innovation in material science. The development of new metamaterials and advanced composites for spacecraft hulls, materials that can shield against cosmic radiation, withstand wild temperature fluctuations, and protect against micrometeoroids, is a direct technological offspring of our desire to venture into the silent, hostile emptiness between worlds. Perhaps the most profound creative spark provided by the void is its power to force a paradigm shift, confronting a true unknown. A complete emptiness where our existing laws of physics may break down requires us to think in radically new ways. It demands not just new answers but entirely new questions. This is where the most groundbreaking innovations are born. The void forces us to abandon comfortable assumptions and consider possibilities that would seem ludicrous in a more familiar context. It is the ultimate sandbox for the theoretical physicist, the cosmologist, and the engineer, a realm with no rules where they can play with the most fundamental concepts of reality. From this speculative play have emerged ideas like quantum foam, cosmic strings, and brain worlds, each one a creative masterpiece of human imagination aimed at painting a picture on the darkest canvas imaginable. In this light, the shadows we seek in the intercosmic silence are completely transformed. They are no longer just problems to be solved or ominous threats to be feared. They are opportunities. Each one is a prompt for a new story, a new equation, a new invention. They are the starting points for journeys of creation that span generations. The void, therefore, is not an end point. It is a beginning. It is the silent, dark nursery where the seeds of future progress are sown, waiting for the light of human curiosity to help them grow. By embracing the void's immense potential, we fundamentally change our relationship with the cosmos. Our journey becomes more than a quest for knowledge. It becomes a grand, collaborative act of creation, a deliberate and beautiful effort to fill the silent darkness with the light of our understanding, our technology, and our ever-expanding sense of what is possible. But as our technological reach extends further into the theoretical, we must pause and ask a deeply human question that transcends our capability. Do we have the right to fill the silence? For centuries, exploration has been an unquestioned human impulse, a drive to climb the next mountain and cross the next ocean. Yet the intercosmic void presents an ethical frontier of an entirely different magnitude. It is not merely a new territory to be mapped. It is potentially the most pristine, ancient, and fundamental state of existence, the very ground of being from which all universes may have sprung. To venture into it with our probes and our experiments is not like sailing uncharted seas. It is more akin to entering a sacred, silent cathedral that has stood empty for all of eternity, and we must ask what gives us the right to shatter that eternal quiet with our footsteps. This is no longer just a question of what we can do, but what we should do, forcing us to balance our boundless curiosity with a newfound cosmic responsibility. The most stark and terrifying risk lies in the possibility that our very act of observation could trigger an irreversible cataclysm. This is not the stuff of science fiction, but a legitimate hypothesis derived from quantum field theory known as vacuum decay. Imagine our universe is not in its most stable possible state, but is instead perched in a precarious false vacuum, a valley of stability that is not the lowest point on the cosmic energy landscape. Our entire reality, with its specific laws of physics that allow for atoms, planets, and life, depends entirely on this delicate balance. A high-energy experiment, perhaps one designed to probe the very fabric of space-time or to create a microscopic black hole, could provide just enough energy to push a tiny region of space over that ridge and into the true vacuum. This would create a bubble of a new reality with fundamentally different physics. This bubble would then expand at the speed of light in all directions, its wall rewriting the laws of nature as it passes. There would be no warning. One moment, the universe as we know it would exist. The next, it would be erased and replaced by something utterly alien, where the concept of chemistry is impossible and life is unthinkable. The price of satisfying our curiosity could be the unwitting destruction of all existence, a final, silent end to every story ever told. Beyond this ultimate existential risk lies a more subtle but equally profound ethical dilemma: the potential for cosmic contamination. This principle is already a cornerstone of our planetary exploration. NASA meticulously sterilizes probes sent to Mars or the moons of Jupiter to avoid any possibility of terrestrial microbes hitchhiking a ride and irrevocably contaminating a pristine alien ecosystem, which would destroy our ability to ever know if life there was truly indigenous. Now expand that concept to a multiversal scale. If the void is indeed a nursery for nascent universes, or if it contains other, fully formed realities, our mere presence could be an act of irreversible pollution. Our physics, our quantum signature, even our conscious observation might seep into these virgin realms, altering their development in ways we cannot predict or control. We would be the invasive species on a cosmic scale, the bull in the china shop of creation. Do we have the right to impose our footprint on realities that have evolved or could evolve entirely independently of us? The precautionary principle, which advises erring on the side of caution when faced with potentially catastrophic and irreversible outcomes, would suggest we should not. It calls for a humility born of wisdom, arguing that the sheer scale of the potential downside demands that we restrain our ambition. This conversation inevitably leads us to the mind-bending simulation hypothesis. If it is even remotely possible that our universe is not base reality, but an artificial simulation running on some unfathomably advanced computer, then our attempts to probe the void take on a completely different ethical dimension. Poking at the boundaries of our simulated universe could be seen as a form of hacking, an attempt to break out of our designated parameters. How would the creators or users of this simulation react? Would they see it as a fascinating development or as a malicious act that threatens the integrity of their construct? Our probing could be met with indifference, with curiosity, or it could prompt them to simply hit the reset button. Furthermore, if we are in a simulation, then the void beyond our universe might not be a natural phenomenon but the underlying architecture, the code, the hardware, the firewall. Tampering with it could have unintended consequences that cascade through other simulations or even into the base reality, making our ethical responsibility not just to ourselves, but to beings and realities we cannot even conceive of. Philosophers like Martha Nussbaum offer a framework for this deliberation with her capabilities approach, often applied to human development but strikingly relevant here. She argues that the moral thing to do is to allow every being to achieve its inherent potential, to flourish according to its nature. Applying this to the cosmos, we might ask, what is the inherent potential of the void? Is it a silent emptiness meant to remain untouched, a sacred preserve of nothingness? Or is its potential to be a substrate for creation, a resource to be used? If the void contains other forms of existence, do we have a moral obligation to ensure they too can flourish according to their own nature without our interference? This perspective argues for a form of cosmic conservation, a principle that some realms should remain wildernesses forever off limits to development, not out of fear, but out of respect for their intrinsic value and right to exist undisturbed. It transforms the void from a challenge to be overcome into a neighbor to be respected. All of these scenarios force us to confront a deep and necessary tension. the relentless pursuit of knowledge versus the profound duty of stewardship. Is the universe and the meta-universe beyond it ours to explore and exploit, or are we merely temporary inhabitants, guests in a cosmos of unimaginable grandeur, with a responsibility to leave it as we found it? This is not just a scientific question, it is a philosophical and spiritual one that gets to the very heart of what it means to be a conscious species. The intercosmic silence has persisted for eternity. It is the ultimate wilderness. To venture into it is an act of incredible audacity. We must decide if we are entering as respectful explorers, mindful of the sacred mystery we are engaging with, or as conquerors, driven solely by the belief that everything that can be known must be known, regardless of the cost. The shadows we seek to illuminate may be best left undisturbed, not out of fear, but out of a newfound maturity, a recognition that some mysteries are meant to be preserved, and that true wisdom lies in knowing where to draw the line between understanding the cosmos and violating its silent, ancient peace. Imagine a concert hall, the audience settled in, a pianist poised at the keys. He lifts his hands and then does nothing. For 4 minutes and 33 seconds, the only sounds are the rustle of clothing, a distant cough, the hum of the air conditioner. This is John Cage's infamous 1952 composition, 433, a piece that is not 4 minutes of music, but 4 minutes of deliberate, framed silence. Cage wasn't trying to trick his audience, he was issuing a profound challenge. He asked us to reconsider what music is, to find the symphony in the ambient noise of our own existence, and to hear the beauty in nothingness. In a single, radical gesture, Cage turned a concert hall into a vessel for contemplating the void, making the silence between notes not just a pause, but the entire point. This artistic revolution is a perfect mirror for our cosmic journey. Just as Cage taught us to listen to silence, we are learning to observe the vast, intercosmic quiet, discovering that what appears to be nothing is, in fact, teeming with its own kind of music. This exploration of silence has blossomed into entire genres of music designed to evoke the emotional and spatial qualities of emptiness. The ambient works of Brian Eno are a perfect example. His landmark 1978 album, Ambient One, Music for Airports, was created to be as ignorable as it is interesting. It doesn't demand your attention with melody and rhythm. Instead, it creates an atmosphere, a sonic space you can inhabit. The music is built from slowly evolving tape loops, sparse piano notes, and soft synthesizer pads that drift in and out of phase like clouds in a vast sky. Listening to it feels like floating, untethered, in a gentle void. It doesn't describe the cosmos, it sonically simulates the feeling of being adrift within it, using sound to craft an experience of weightless, peaceful expanse. This approach is a far cry from the dramatic, crashing chords of a Holst's The Planets, which paints pictures of celestial bodies. Ambient music paints the space between them, giving us an auditory texture for the void itself. But how do you compose the sound of a place where sound cannot exist? This is the fascinating paradox at the heart of this artistic endeavor. In the vacuum of space, there is no air to transmit pressure waves, so there is no sound as we know it. The true intercosmic void is the most silent place imaginable in a physical sense. Artists, therefore, face a unique challenge: how to represent this absolute sonic absence using the very thing that is absent, sound. They solve this not through literal reproduction, but through powerful metaphor and sensory suggestion. One primary technique is minimalism. Composers like Arvo Pärt or Henrik Gorky use stark, simple harmonies and vast stretches of time between musical events. A single, sustained chord held for a minute or more can create a breathtaking sense of spatial vastness and temporal suspension, making the listener acutely aware of the passing of each second, much like an astronaut watching a distant star. Another method is the use of dissonance and unresolved tension. A clashing, discordant note that never finds its harmonic home can create a feeling of unease and isolation, perfectly mirroring the existential uncertainty we feel when confronting the infinite. Conversely, the strategic use of extremely low frequencies, the kind you feel in your bones more than hear with your ears, can simulate the immense gravitational rumble of a black hole or the primal hum of the universe's birth phenomena that are silent to our ears but are, in reality, titanic vibrations in the fabric of spacetime itself. Sci-fi film sound designers are masters of this craft. The terrifying silence of the vacuum in movies like Alien or Gravity is often punctuated by the character's own breath and heartbeat, heard from inside their suit, a stark reminder of their fragile, tiny presence against the overwhelming quiet. And when sound is used, like the iconic, deafening blast of the spacecraft engine in Star Wars, it's a dramatic violation of that silence, a thrilling but entirely fictional addition that reminds us true space has no sound at all. This auditory journey does more than just provide a clever analogy. It adds a crucial, missing dimension to our understanding of the cosmos. We have spent this entire series trying to conceptualize the void through mathematics, physics, and philosophy. But music allows us to feel it. It bypasses the intellectual centers of our brain and speaks directly to the emotional and the visceral. The deep unease evoked by a low, dissonant drone connects us to the primal fear of the abyss. The tranquil peace of a soft ambient pad connects us to the sublime beauty of that same emptiness. It allows us to experience the awe and the terror not as abstract concepts, but as bodily sensations. In this way, the universal language of music, or in Cage's case, the universal language of its intentional absence, becomes our most powerful tool for empathy with the cosmos. We cannot yet send a microphone into the void between universes, but we can use the tools of art to build a bridge of feeling, to hear the echoes of that great silence within ourselves, and in doing so, comprehend its profound nature in a way equations alone can never fully convey. Our journey through the intercosmic silence has revealed it as a quantum nursery, an entropic graveyard, and a higher dimensional labyrinth. But what if this vast unknown could become more than a subject of study? What if it could become a home? As we stand on the precipice of becoming a spacefaring civilization, the greatest void may represent our ultimate frontier, not as a destination for mere exploration, but as a potential sanctuary and a canvas for survival on a scale once confined to our wildest science fiction. The challenges are beyond monumental, but the human impulse to reach beyond our cradle has always been fueled by seemingly impossible dreams. Imagine a civilization so advanced that its energy needs dwarf the entire output of every star in its home galaxy. Such a society might embark on the most colossal engineering project conceivable, building a Dyson sphere not around a star, but around a region of pure void. This megastructure would be a hollow, artificial world of staggering scale, its inner surface illuminated by contained fusion or some yet unknown physics, creating a self-contained biosphere adrift in the absolute darkness. The motivation wouldn't be just energy collection, but ultimate security. Positioned far from the gravitational turmoil of galaxies, safe from the death throes of stars like supernova, and insulated from the potential dangers of other intelligent life, this void-bound ark would be the perfect fortress, a preserve for life and knowledge designed to outlast the slow, entropic death of the rest of the cosmos. The materials for such a structure would likely need to be harvested from entire galaxies, broken down into their fundamental atoms and reassembled in the silent dark, a testament to a power that appears godlike to us now. For those not content to wait out eternity in a static shell, the void could become the ultimate highway. Generation ships, vast self-sustaining ecosystems housed within vessels the size of cities, could be designed for journeys of unimaginable duration. Their destination wouldn't be another star, but another universe, using theoretical physics that might one day allow for tunneling through the meta-universe foam. These ships would cast themselves into the intercosmic silence, their crews and their descendants living and dying over millennia-long passages. The psychological adaptation required for such an existence is difficult to fathom. Human culture would have to evolve around the ship itself as the entire universe, its history and maintenance becoming a central religion, its endless journey the core of all myth and meaning. The eternal silence outside would cease to be terrifying and would instead become the natural state of things, the peaceful backdrop to a civilization in transit. Perhaps the most compelling use of the void is as a buffer against the ultimate cosmic disasters. We've discussed the terrifying possibility of vacuum decay, a true universe-ending event where the laws of physics themselves are rewritten at the speed of light. If a neighboring universe were to undergo such a phase transition, the wave of annihilation would be unstoppable. Our only hope for survival might be to use the void itself as a shield. By placing colonies or data archives on journeys deep into the intercosmic gaps, we could create a backup of humanity, putting enough distance between ourselves and the cataclysm that the wave of destruction might never reach us before the natural expansion of the meta-universe stretches the space between us to infinity. In this scenario, the void is our cosmic lifeboat, the only place where information and consciousness could potentially survive the end of everything we know. The obstacles to such a future are, of course, so vast they border on the inconceivable. The energy requirements alone for any of these projects defy our current understanding of physics. We would need to master energy sources that tap into the quantum vacuum or the fabric of spacetime itself. The biological and psychological hurdles are equally daunting. How does the human mind cope with a reality where the night sky is not a tapestry of stars, but a perfect and eternal blackness? Entire fields of void psychology and environmental design would need to emerge to prevent madness and despair, perhaps involving advanced virtual realities that simulate planetary environments or genetic adaptations that reduce our innate need for celestial patterns and daily cycles. Yet, the history of human progress is the story of transforming the impossible into the routine. The silent void between universes represents the final and greatest challenge, one that could unite our species for millennia to come in a project of cosmic preservation and renewal, turning the great emptiness from a symbol of oblivion into the very thing that ensures our eternal legacy. And so we return from the edge of everything, our minds still echoing with the profound silence we have spent this time contemplating. We set out to explore a void, a nothingness, and instead discovered a realm teeming with the most breathtaking possibilities. We have wandered through quantum nurseries where whole universes flicker into being from the sheer potential of emptiness. We have stood before the chilling, inevitable fate of heat death, the ultimate silence toward which all things seem to drift. We have peered into hidden dimensions and walked the landscapes of string theory, where the void is not a blank slate but a complex, higher-dimensional architecture. We have listened to the ancient stories and the modern equations, and found they often whisper the same truths about the creative power of nothingness. This journey has never been just about the physics, though the science lights the path. It is about what the void reflects back to us about ourselves. It holds up a mirror to our deepest fears of isolation and irrelevance, but also to our most profound capacities for wonder, creativity, and resilience. The intercosmic silence is the ultimate canvas, and upon it we have projected our gods, our monsters, our equations, and our art. It is a Rorschach test for the human spirit, and what we see in its inkblot depths tells a story about our timeless need to find meaning, connection, and beauty in the face of the infinite unknown. Whether through the telescope, the meditation cushion, or the artist's brush, our engagement with the mystery is what makes us human. The greatest lesson the void teaches is that curiosity is its own reward. The answers may forever hover just beyond the cosmological horizon. The shadows may never fully resolve into clear forms, but the act of asking the questions expands our world. It pushes the boundaries of what we believe is possible, both in the cosmos and within ourselves. This exploration is a continuous conversation, a dialogue between the silent, external universe and the vibrant, internal universe of human consciousness. One cannot be understood without the other. Thank you for lending your imagination to this journey through the darkness and the light. If these ideas have resonated with you, if they have sparked a new thought or a new question, we would be deeply honored if you shared that spark with others. Let us know in the comments what shadows you see in the silence, and subscribe to join us on the next adventure into the mysteries that surround us. Keep looking up and never stop listening.